Beneath the surface of our planet lies a realm untouched by time, unseen by sunlight, and still unknown to most of science. The ocean, covering more than 70% of Earth's surface, is not a single, unified body of water. It is a layered world, a collection of depths, trenches, ridges, and currents that move with slow, rhythmic purpose. Of this enormous aquatic kingdom, more than 80% remains unexplored. Not merely unseen, but unmapped, unmeasured, unfelt. It is a territory as mysterious as the dark side of the moon, and in some ways, even more so, because it is here, on our own planet, just beyond the reach of our fingertips. The deep ocean begins where the light ends. As you descend from the surface, sunlight weakens, filtered out by layer after layer of water, until eventually, there is nothing but darkness. Below this threshold lies the abyss, a space untouched by the sun for millions of years. The pressure increases with every meter. The temperature drops, and the very composition of life begins to change. Gone are the fish and coral of the shallow reefs. Gone are the playful mammals and darting schools of color. What remains is something else entirely. Something slower, stranger, older. The creatures of the deep are shaped not by competition for territory or the changing of seasons, but by isolation, silence, and pressure. They do not hunt in packs or nest in trees. They do not bask in light or rely on warmth. Instead, they drift or cling, glow or vanish, feed once in a lifetime or never at all. Their forms can appear alien, jagged, translucent, immense, or impossibly small. Some possess organs that have no analog on land. Others survive with no eyes, no pigment, no skeletons. Every one of them is a whisper from a world that resists classification. Imagine standing on the edge of a vast black plain, with no horizon, no sky, no gravity to tell you which way is up. This is the stillness of the deep. It is not the emptiness of space, nor the quiet of a forest night. It is a different kind of silence, dense and full, like the pause between ancient breaths. There are no currents to disturb the silt, no light to cast shadows. Just cold, darkness, and the slow movement of water across a landscape that has never known disturbance. And yet, life thrives here. Not in abundance, perhaps, but in resilience. It exists in impossible places, clinging to thermal vents that belch scalding minerals into freezing dark, hanging motionless in a water column, suspended in stillness for days or even weeks. Some species here reproduce without mates. Others grow without aging. Many have never been seen alive by human eyes. We know of them only through brief glimpses, faint outlines caught by deep-sea rovers, vague forms half revealed in sonar sweeps, fragments pulled up by nets and studied under microscope. There is something reverent about encountering life that was never meant to be seen. Something humbling about the realization that these creatures have lived and died for eons without our knowledge. They do not need us. They do not respond to our curiosity. They are complete in their own ways, living in the same earth, but not the same world. The deep ocean offers no easy answers. It gives us fragments of stories, a glowing tendril here, a shadowy figure there, a strange call echoing through the water with no source to explain it. These are not puzzles to be solved, but mysteries to be experienced. Their value is not in what they reveal, but in how they remind us of the vastness of what we do not know. And still we return. We send machines into the deep, hoping for a glimpse, a sound, a shape. We press against the limits of pressure and darkness, just to see what lives beneath the weight of the world. Every discovery is a thread in a larger tapestry, one we may never fully see. But that does not lessen its beauty. In this journey, we do not seek to dominate or define. We seek only to understand, to listen, to observe. We enter the deep not as conquerors, but as guests. There is no rush here, no destination, no climax. There's only the slow unfolding of mystery, the gentle pull of wonder. Let us begin by pausing. Let us drift into the quiet. Let us sink beyond the boundaries of what we know and into the soft, unending dark. The deep sea awaits, not with answers, but with presence. Not with explanation, but with depth. In this place where time dissolves and silence speaks, we begin to listen. As one descends deeper into the ocean, the familiar begins to fade. Above, the surface shimmers with sunlight and movement, waves, wind, the flickering reflections of a world that makes sense. But the deeper you go, the more that world dissolves. Light thins, then vanishes. Color disappears. Red fades first, then orange, then yellow. By the time you pass a few hundred meters, only blue remains, cold and dim. And beyond that, nothing. There is no sun below 1,000 meters. There is only black, an endless, absolute black. This is where the abyssal zone begins. It stretches from about 4,000 meters to 6,000 meters below the surface, a vast and silent realm that covers over half of the ocean floor. It is one of the largest environments on Earth, and yet it remains almost completely unknown. Deeper still, in the ocean's trenches and folds, lies the Hadal Zone, named for Hades, the underworld of Greek mythology. It is the most remote and inaccessible place on our planet, existing in narrow trenches that plunge to depth beyond 11,000 meters. These two zones together form the true bottom of the sea. Together, they hold secrets untouched by sunlight, unreachable by most machines, and unreadable by the language of land. In these depths, pressure builds with silent, relentless force. Every 10 meters down adds another atmosphere of pressure. By the time you reach the abyssal zone, you are under the weight of 400 to 600 times the atmospheric pressure of sea level. At the bottom of the Hadal trenches, it is more than 1,000 atmospheres. This is pressure not just of weight, but of history, of millions of years of sediment pressing down, of water folded into water, of darkness layered upon darkness. There is no sound, not in the way we understand it. No crashing of waves or calls of whales. Just the occasional groan of shifting tectonic plates or the distant pop of a volcanic vent. But mostly there is stillness. A stillness so deep it seems to suspend time itself. In this world, nothing is fast. Movement is slow and rare. Life is cautious, deliberate. The seafloor here is a desert of fine sediment, sometimes broken by ridges, mounds, or chasms. There are underwater mountains taller than the Alps, trenches deeper than Everest is tall. But we do not see them. They exist as outlines on sonar maps, as vague suggestions in the minds of scientists. No one has walked there. No one has seen them up close. They are shapes beneath a blanket of water and time. Despite the crushing pressure, the freezing temperatures, and the absence of light, life persists. Not everywhere, not in abundance, but it is there. It flickers in bioluminescent flashes, glides slowly to the water column, rests in the folds of the sediment. The creatures here are strange, often translucent, often soft-bodied. Their biology adapted to survive conditions we can scarcely imagine. They have no need for strong bones or rapid movement. They do not flee. They endure. In some places, life clusters around thermal vents, cracks in the seafloor where heat and minerals pour out from the Earth's interior. Here, bacteria form the base of a unique food web, feeding tube worms, blind shrimp, and creatures that exist nowhere else on Earth. These vents are islands of warmth and chemistry in an otherwise cold and inert landscape. They glow softly in the dark, a kind of inverse campfire, where life huddles not for light but for energy. Elsewhere, life survives in stiller, quieter forms. See cucumbers that feed on detritus drifting down from above. Amphipods that scavenge the remains of animals fallen from higher zones. Gigantic isopods with armored plates and slow movements. Some of these creatures have never been seen alive, only collected in partial or distorted form by deep-sea trawls or robotic arms. What is perhaps most haunting about these zones is their invisibility. They are not just remote, they are silent, hidden beneath layers of currents, sediment, and technology. We have sent submersibles down into them only a handful of times. The deepest points of the Hadal Zone remain largely untouched, known only by depth readings and vague outlines. And yet, they are part of our world, beneath our continents, beneath our feet, beneath the maps we draw. To understand the abyssal and Hadal zones is to accept a kind of humility. These are not places we will colonize or terraform. They are not resources waiting to be mined. They are deeper than our understanding, broader than our ambition. They exist in quiet defiance of exploration, a reminder that the Earth still holds mysteries no satellite can see, no algorithm can predict. In the darkness of these zones, where even sound is subdued and time stretches out like the horizon, there is no urgency. The ocean waits. It has waited for millions of years. It will wait for millions more. It does not call us, but it does not turn us away. It simply is. To float in this black below, even in imagination, is to drift away from the noise of the surface, the rush, the explanation, the light. It is to enter a place where the rules are different, where stillness is strength, and where life, though rare, is all the more miraculous for its endurance. The abyss does not explain itself. It offers no revelation. It only opens, slowly, to those who are willing to listen. In the depths where no sun has ever reached, where pressure weighs heavy and cold wraps around every living thing like a second skin, time begins to lose its meaning. Down here, evolution moves slowly. So slowly it's almost imperceptible. There is no rush, no competition for the warmth of light, no changing seasons to provoke transformation. In this timeless ocean, creatures exist not as product of constant change, but as survivors of ancient conditions that have remained nearly the same for millions of years. They are not echoes of the past. They are the past, alive, breathing, and slowly swimming through the same waters their ancestors knew before the rise of mountains, before the first bird sang, before the continents took their current shape. Among the most famous of these ancient beings is the coelacanth, a deep-sea fish thought to have gone extinct at the end of the Cretaceous period, more than 60 million years ago. For a long time, it existed only as a fossil, a strange lobe-finned fish with no apparent connection to the modern world. But in 1938, a living coelacanth was discovered off the coast of South Africa, its body still bearing the same archaic fins, the same thick, scaled armor, the same slow, deliberate swimming motion. It had not gone extinct. It had simply gone unnoticed, hiding in volcanic caves at depths too great for ordinary fishing lines or curious divers. The world changed around it. It did not change with the world. The frilled shark is another relic of deep time. With its long, eel-like body and rows of needle-sharp teeth curled inward like barbed wire, it seems more like something imagined in a myth than something real. Yet it exists, swimming in the blackness of the continental slopes, rarely seen, never common. Its physiology speaks of an ancient origin, primitive gills, flexible jaws, and a reproductive cycle that may last years rather than months. It does not need speed. It does not require novelty. It has mastered the art of waiting. These living fossils are not stuck in the past. Rather, they are perfectly suited to a part of the world that has not changed in the ways the surface has. The deep ocean is consistent. It does not freeze and thaw. It does not burn or bloom. It does not rise with the sun or sleep in the dark. It is always dark, always cold, always immense. For a creature adapted to these conditions, evolution has little to offer. The shape that worked 200 million years ago still works now. There is no need for reinvention. In the midwater columns, among gelatinous forms and flickering lights, one can find the nautilus, another ancient form, with a spiraled shell and tentacles reaching out from a living fossil's mouth. Its ancestors date back nearly 500 million years. It survives by floating, by drifting, by retreating into its shell when threatened. Its presence is quiet. Its survival is uninterrupted. Even stranger the hagfish, eel-like scavengers that ooze slime in enormous quantities and have no jawbones. They feed on dead animals, burrowing into carcasses and consuming them from the inside out. Fossils show that the same body plan, soft, jawless, unblinking, existed long before the dinosaurs. They do not hunt. They do not flee. They endure. Their slime, their slow movements, and their unusual physiology are not primitive. They are simply effective. The horseshoe crab, though not truly a deep-sea creature, shares a similar story. Found in shallow coastal waters, it has remained mostly unchanged for over 450 million years. It survived 5 mass extinctions. Its copper-based blood is harvested for medical testing, though the animal itself still lives much as it always has, crawling along muddy seafloors, unseen and mostly unbothered. To observe these animals, or even to know them, is to confront a version of life that does not align with our sense of urgency. We are accustomed to the new, to species that adapt, grow, branch off into new forms. But here, deep beneath the waves, nature whispers a different story. It tells of survival through stillness, through consistency, through quiet. These animals are not lesser for being old. Their designs are not outdated. In fact, they are reminders that some solutions are so elegant, so complete, that no change is necessary. In an ocean without time, there is no need to evolve when the body already fits the environment like a glove. These are not frozen artifacts. They are functioning, breathing, sensing lives, creatures that outlived empires, outlasted ice ages, and continue still. Their existence challenges the way we understand progress. Evolution does not always move forward. Sometimes it pauses. Sometimes it circles. Sometimes it stays exactly where it is, holding steady while everything else shifts and spins. In the deep ocean, this is not only possible, it is often preferable. When every calorie is precious, when every movement costs energy, efficiency becomes sacred. There is no room for extravagance. Only what works endures. As the world above changes rapidly, technologically, climatically, ecologically, there is comfort in knowing that something ancient still breathes in the dark, that somewhere beneath kilometers of water and pressure, something from before time, as we know it still swims. It does not ask for attention. It does not offer explanation, but it is there. And perhaps that is what draws us to these creatures, not just their age, but their silence. They do not try to tell us anything. They are not symbols. They are not metaphors. They are simply alive, and in their quiet, in their slow pulsing to the dark, they remind us that life is vast, that the present is layered with the past, that time in the deep ocean is not a line but a pool, still, cold, endless, and full. In the vast blackness of the deep sea, where no sunlight penetrates and the cold presses against every form of life, there exists a strange and beautiful phenomenon, light born from darkness. It is not borrowed light, not reflected sunlight or distant starlight, but a glow made from within, a living fire that dances in slow patterns across the ocean floor and mid-water columns, pulsing softly in the stillness. This light, called bioluminescence, is one of the most haunting features of the deep, a kind of silent language and invisible art. It is light with purpose, created by life that knows nothing of the sun. Here, thousands of meters beneath the surface, bioluminescence becomes more than beauty. It is a survival strategy. It can lure, deceive, warn, attract, hide. In a world where darkness is a fault, light is a signal, carefully given, carefully received. The organisms that emit it are masters of control, glowing only when needed, pulsing in patterns refined to millennia. One of the most iconic deep-sea creatures is the anglerfish. Its mouth is filled with long, curved teeth that point inward like the bars of a trap. But it is not the mouth that defines it. It is a glowing lure that dangles from its forehead, a fleshy filament tipped with a light-producing bulb. This light is not decorative. It is bait. The anglerfish remains perfectly still, hidden in the dark, while its light pulses softly in the water. Small prey, drawn by curiosity or the illusion of safety, swim closer until suddenly the trap closes, the light disappears. The hunt is complete. Other fish, like the hatchetfish, use bioluminescence as camouflage. Their undersides are lined with tiny light-producing organs that mimic the faint glow from above. In the right alignment, they vanish, becoming invisible to predators lurking below. This technique, known as counterlumination, is one of the most effective defenses in the deep. To glow in the deep sea is not always to reveal, but sometimes to hide. Then there are the siphonophores, long, gelatinous colonies made of many individual animals that function together as one. Some species of siphonophores can stretch for dozens of meters, their bodies trailing through the water like living ribbons. Many of them glow with cascading patterns of light, undulating through the dark like a current of electricity. This glow can be a warning or a distraction, or perhaps a way of confusing predators who don't know where one end of the creature begins and the other ends. Watching them is like witnessing a living chandelier drift through black space. Each flicker soft, slow, and deliberate. Some jellies flash explosively when disturbed. A single touch from a passing creature can trigger a pulse of blue or green light, as if the ocean itself is reacting to the intrusion. This sudden burst may disorient the predator, or attract larger predators that might attack the attacker. Others emit glowing particles into the water as a kind of smoke screen, leaving behind a trail of light that allows them to slip away unseen. There are worms that sparkle with pinpricks of light when they swim, like stars scattered across a black sky. There are shrimp that release glowing clouds of chemicals, staining the water with pale blue as they retreat into the dark. There are squid that flash from their sides and arms, their bodies communicating through silent flashes and shifting patterns. What binds all of these creatures is not just their ability to produce light, but their relationship with darkness. In the deep sea, darkness is total. It is not like the night on land, where stars shine and eyes adjust. It is a complete absence. In that absence, light becomes rare and therefore powerful. It becomes a tool used carefully. Some use it to hunt, others to hide, still others to find a mate, signal a warning, or mark territory. The chemistry behind bioluminescence is, in many cases, similar across species. It often involves a molecule called luciferin and an enzyme called luciferase. When they react, often triggered by oxygen or calcium ions, they produce a cold light. It emits no heat. It does not burn. It simply glows. And yet, despite the shared mechanism, the forms it takes are incredibly diverse. Some light is steady. Some flickers. Some is colored blue, green, even red, though red is rare, as most deep-sea animals cannot see it. There is something deeply poetic about the fact that so much light exists where no one can see it. These displays are not for us. They are not for study or spectacle. They evolved in silence, shaped by need, sharpened by time. They are performances in the dark, seen only by the few other creatures who live within that black world. Bioluminescence challenges our sense of what life needs to survive. On the surface, we rely on light for everything, for warmth, for food, for vision, for rhythm. But in the deep, life makes its own light. It creates what it needs. It turns inward and finds, even in the absence of sun, the ability to glow. Some of the most mesmerizing footage ever captured by deep-sea submersibles shows these glowing beings drifting slowly past the lens. Tiny bursts of moving light in an ocean that would otherwise be black. They pulse like breathing. They drift like thought. They remind us that in the most extreme places, life adapts not by overcoming the environment, but by becoming part of it. To watch these creatures is to be invited into a kind of silent dance. Not choreographed, not rehearsed, but ancient and instinctive. A ballet not for applause, but for survival. A performance not seen by audiences, but by predators and prey, by potential mates and passing strangers. Light here is not an accessory. It is a message. It is a story. It is a rhythm known only to those who live far beneath the noise. In the end, bioluminescence is not just a scientific phenomenon. It is a quiet defiance against darkness, a way for life to say, I am here. I exist, even in the blackest corners of the earth, even in the deepest silence. I shine, in the deep, where light does not reach and where the ocean is measured in crushing silence. Some creatures grow beyond the imagination of scale. They do not roar or thrash. They do not breach the surface in grand displays. They move without announcement, slow, vast, and silent. These are the giants of the deep, beings of immense size that drift in the blackness, barely seen, rarely understood. They are not myth, though many were once thought to be. They are real, they are alive, and they remain just beyond the reach of certainty. Among them is a giant squid, a creature that for centuries was known only from legends and from the battered remains washed ashore. Tentacles the length of a ship's mast, beaks the size of dinner plates. Sailors call them krakens. Imagine them pulling entire vessels beneath the sea. And yet, for all the fear and folklore, no one had seen a giant squid alive in its natural habitat until the 21st century. It was not until cameras reached deep enough and waited long enough that the world glimpsed this elusive giant on its own terms. Its body was long and fluid, its eyes the largest of any animal, its movements ghostly and slow. It did not roar. It shimmered, then vanished into the dark. Even larger, though less famous, is the colossal squid. Heavier than its cousin, it lives even deeper, in colder, darker waters. Very few have been seen. Few are still recovered intact. The beaks found in the stomachs of sperm whales are sometimes the only evidence of its existence, testimony that a battle between giants occurs in the deep, unseen by any surface eye. The colossal squid's tentacles bear rotating hooks, its body massive and compact. It is not agile. It does not chase. It waits, and perhaps it never needs to rise, living its entire life in darkness, unseen. There are also jellyfish of astonishing size, creatures without bones or brains, drifting silently with arms trailing behind them like living curtains. The lion's mane jellyfish, found in colder northern waters, can have tentacles over 30 meters long. It is not rare, but it is rarely seen in its full scale. In the deep, where other jellyfish live, some grow to sizes we can barely comprehend. They glow, undulate, and pulse through the black, slow and seemingly indifferent to the world around them. They are not hunters in the way we understand it. They simply move. Their tentacles do the work, delicate filaments that paralyze and gather whatever drifts too close. The sheer scale of these beings challenges our expectations. In the deep sea, food is scarce, movement is costly, and survival is uncertain. So why, in such an unforgiving environment, does size emerge? Some scientists point to deep-sea gigantism, a pattern where certain species grow larger at greater depths. The reasons are debated. Colder temperatures may slow metabolism and promote longevity. Lack of predators may allow slow-growing species to reach greater size. Or perhaps, in the immense volume of the deep ocean, large size becomes an advantage for long-distance drifting, energy storage, or reproduction. Not all of these giants are confirmed. Some remain known only through stories or single sightings, vague outlines caught on the edge of submersible light. Strange shapes passing in sonar shadows. There are tales of massive octopuses seen off deep-sea rigs, of creatures so large they seem to stretch beyond the camera's reach. Others are only inferred. Bite marks on submersibles, enormous tentacle scars on whale carcasses, sudden disturbances in the silt of the seafloor. These are not proof, but they're suggestions. Echoes of a scale we have yet to measure. The deep ocean allows for mystery because it is vast and silent. A creature the size of a school bus could live for decades and never be filmed. A jellyfish the width of a small house could pulse quietly through the midwater, unseen by any eye. We do not know how many of these giants exist, or how they live, or how often they reproduce. They may live for centuries. They may drift for years without feeding. They may never see the surface. And perhaps they do not need to. These giants do not crash or chase. Their power lies in stillness. They do not need to dominate. They endure. They pass through the water without resistance, using its density to support their mass. A squid can change direction with a single pulse of its mantle. A jellyfish can disappear in the same current it entered. And yet, they are present, massive, soft, and quiet. Their eyes, when they have them, are often immense. The giant squid's eyes are the largest in the animal kingdom, capable of detecting faint glimmers of bioluminescence in the far distance. In a world without light, this sight is not for color or beauty. It is for motion, for warning, for survival. The eye becomes a sensor, a tool of adaptation more than awareness. There is something humbling in knowing these creatures are not rare because they are fragile, but because they are hidden. They are not disappearing. They are simply out of reach. They have always lived below, in the layers of the ocean that few dare enter. Their world is not new. It is ancient. It does not need our gaze to validate it. In the surface world, large animals often demand attention. Elephants, whales, bears. But the giants of the deep ask for no such thing. They make no sound. They leave few traces. They do not gather in groups or perform for crowds. They live in stillness, and in that stillness, they remind us that size is not always accompanied by presence. Some of the largest creatures in the ocean are also the most elusive. To imagine them is to feel something like reverence, not fear, but respect for a form of life that exists beyond our control, beyond our measurement. They move through a space that does not belong to us. They thrive in conditions that would collapse our bodies and freeze our breath. And they do so without noise, without aggression, without haste. In their presence, or even the thought of their presence, we are made small, but not in a way that diminishes us. Rather, we are returned to a sense of perspective, a sense that the ocean is not a place we have conquered, but a place that continues to hold its secrets close. The silent giants of the deep are not myths. They are not dreams. They are life, drawn in slow lines across the dark canvas of the abyss. They are still drifting now, somewhere far below, enormous and unseen. In the deep, where movement is rare and stillness defines a landscape, not all predators swim. Some remain anchored, rooted like the plants they resemble, unmoving, silent, and deadly. They do not chase. They wait. These are the sessile hunters of the abyss, creatures that appear to be no more than decoration, yet function with slow, efficient violence that defies their appearance. They are not flora. They are fauna in disguise. Among them, the harp sponge and the hunter coral are among the most strange and least understood. The harp sponge, first discovered in the cold depths of the Pacific Ocean, looks like an instrument sculpted from bone. Its delicate structure rises in vertical veins, branching like the strings of a harp. At first glance, it appears lifeless, just another filter feeder passively drifting with the current. But closer inspection reveals a hidden strategy. Each of those vertical filaments is lined with tiny barbed hooks, specialized cells designed not to trap debris, but to capture living prey. Small crustaceans and passing zooplankton brush against the sponge's filaments and become ensnared. Once caught, they are slowly enveloped by the sponge's tissues and digested. There is no movement, no struggle, just the quiet absorption of life into structure. This method of feeding is remarkably rare among sponges, most of which rely on passive filtration of water to gather microscopic food. The harp sponge is different. It is not passive. It is patient. It has evolved in such a way that it no longer sifts for nutrients, but actively captures. And yet, its strategy is not built for speed or aggression. It is built for certainty. Every structure is shaped for efficiency, angled to catch the flow of water, sharpened to hold fast whatever it touches. Further into the depths, other sessile predators live by similarly quiet means. Among them are deep-sea corals that do not merely sting, but kill. In particular, the stinging, predatory corals of the genus Hydractinia, and others remain poorly classified and rarely studied. These organisms resemble ordinary reef corals, stationary, branching, delicately colored, but they're armed with specialized cells that can stun or kill small animals that drift too close. Some species possess nematocysts, tiny harpoons loaded with venom that fire on contact. The prey is paralyzed, held fast, and eventually absorbed into the coral's soft tissues. To watch one of these animals feed is to witness a kind of slow-motion trap. There is no visible attack. The prey drifts, touches, halts. Then the coral's polyps begin to move, not toward the prey, but around it. Tissues shift. Tiny mouths open. Digestion begins. The entire process may take hours. But in the stillness of the deep, time is generous. There is no need to rush. These predators are not common. They exist in places where nutrients are sparse, where movement is rare, and where opportunity must be seized the moment arrives. Evolution has favored patience here, and these animals are masters of stillness. Their shapes blend into the seafloor or rise like delicate sculptures from the rock. To the untrained eye, they are indistinguishable from background. That is their strength. They do not need to hide because they do not appear dangerous. They do not need to move because the current brings their prey to them. In many ways, these creatures defy our expectations of what it means to be a predator. On land, predators are associated with speed, strength, chase, and kill. In the deep sea, where energy is precious and motion is costly, the very concept of predation changes. Here, a predator can be a still shape on a rock, a slow-growing sponge, a coral with hidden venom. They hunt not with teeth or speed, but with form and function, by designing their very structure to ensnare life. What makes them even more mysterious is how little we understand them. Many of these sessile predators remain uncategorized in mainstream biology. Their classification is debated. Their behaviors are difficult to study. Most have never been observed feeding in the wild, only inferred from the remains of prey found tangled in their filaments. Deep-sea expeditions sometimes capture fragments of them, or brief video clips that show a flicker of movement, a glint of structure. But there is no complete picture, just suggestion. These creatures challenge our need to label. They exist at the edges of our definitions. Part plant in appearance, part animal in function. They are fixed to the ground like moss, yet they consume like wolves. They blur the lines between categories we thought were distinct, and in doing so, they remind us how limited our language can be when trying to describe the deep. To see them, even through a screen, is to feel subtle awe, not the awe of size or spectacle, but the quiet awe of design. Every angle, every barb, every hidden mouth has a purpose. These animals have evolved not to survive the harshness of the deep, but to belong to it. To become part of the structure, the silence, the rhythm of slow life in the abyss. Their beauty lies in their contradiction. They are graceful and deadly, unmoving and efficient. In a world where light does not exist, they have found a way to thrive without eyes, without motion, without sound. Their lives are measured not in heartbeats or footsteps, but in the slow accumulation of success. One prey at a time, one passing current, one rare opportunity taken. They are reminders that the ocean does not just hold monsters and mysteries. It holds complexity. It holds forms of life so unlike our own that they seem alien, even as they share the same planet, the same ancestry, the same fundamental spark. In the harp sponge and the hunter coral, we see a kind of stillness that is not empty, but full of quiet intention. A life that waits, perfectly adapted to the black water that flows around it. A predator that does not move, but watches and waits and survives. In the cold, dark waters near the ocean floor, where pressure settles like a second gravity and movement is measured in whispers, there lives a creature that seems more imagined than real. It does not glide like a ray or cut through water like a shark. It drifts, its body soft and strange, its eyes large and ancient, known as the ghost shark, or more technically as a chimera. This animal belongs to one of the most mysterious and least understood lineages in the sea. It is not a shark, though it shares a common ancestor. It is not a bony fish, nor a ray, nor anything else that fits easily into modern taxonomy. It is something older, something that slipped away from the evolutionary crowd and found a quieter path in the deep. Ghost sharks, sometimes called ratfish, rabbitfish, or spookfish, are named less for what they are than for how they appear. Their bodies seem to lack substance, like a shape glimpsed through mist. Their skin is smooth and almost leathery, without the tough, sandpaper scales of true sharks. They possess long, tapering tails and wing-like fins that ripple as they move. Their eyes glow a pale green when caught in light, reflecting the depths where they live. And most striking of all is their head, bulging, soft, sometimes translucent, with a peculiar rabbit-like shape and a long, flexible snout. They've been seen only a handful of times on camera, mostly by deep-sea submersibles or remote-operated vehicles that happen to pass them in their silent roaming. When one is captured on film, it does not flee or attack. It drifts calmly, as if unbothered by the presence of light or machine. It moves with an ease born from a lifetime in stillness. There is no urgency in its path, no sharp turn or darting escape, only drifting. Anatomically, chimeras confuse even experts. Their skeletons are made entirely of cartilage, like those of sharks, yet their jaws are fused to their skulls, an arrangement different from any other cartilaginous fish. They have a venomous spine in front of their dorsal fin, a strange holdover from some earlier time, though its purpose is not fully understood. Some species have long, whip-like tails. Others carry pouches on their heads, used in reproduction. Their teeth are not sharp or pointed, but flat plates used to crush hard-shell prey, mollusks, crustaceans, and other creatures of the seafloor. What sets them further apart is their lineage. Chimeras diverged from other cartilaginous fish over 400 million years ago, long before the age of dinosaurs. They are more ancient than most sharks, more ancient than the trees that now grow on land. In their quiet persistence, they are survivors of a world that has come and gone many times over. They carry in their bodies a history of an ocean that existed before the continents took their current shape, before the coral reefs bloomed, before the first birds took flight. Despite their age and uniqueness, ghost sharks remain elusive. Their habitats are deep, often below 1,000 meters, in regions rarely explored. They do not gather in schools. They do not rise to the surface. They leave no tracks, no trails. And because of this, much about them remains unknown. Their behavior, reproduction, lifespan, and ecological role are topics of speculation more than science. What little is known comes from specimens caught by accident or seen for moments before vanishing into the dark. Even their reproduction is unusual. Unlike many fish, ghost sharks lay eggs in leathery capsules, often called mermaids' purses, which are left to develop on the seafloor. These capsules are rarely found, and when they are often empty, drifted far from where they were laid. It is believed that the young hatch fully formed, miniature versions of their parents, already adapted to the dark world around them. In the mythology of the sea, ghost sharks occupy a special place. They are not the subject of sailors' legends or ancient sea monsters, perhaps because they are too quiet to inspire fear. Instead, they exist on the edges of perception, a flicker in the light, a form that resists naming. Their very presence challenges the neatness of categories, the confidence of science. They are not this or that. They are simply themselves. To glimpse a ghost shark is to be reminded of how much we do not know, of how much lives in the deep without notice, without study, without explanation. They are not waiting to be discovered. They are not secrets meant to be revealed. They are lives, complete and sufficient, drifting in the cold water with eyes adapted to endless dark. In their movement, in their shape, in their very presence, ghost sharks suggest a world older than our understanding, a world still alive beneath our feet, filled with forms that refuse to conform. They are not dramatic. They are not loud, but they're enduring. And in the deep, that is what matters most. There are creatures in the deep that seem to belong to a different reality, being seen not in study or captivity, but in a single flicker of footage, a brief moment of film before vanishing forever. These are the uncatchables. Animals known not through familiarity, but through encounter. They exist in the realm between proof and mystery, recorded just long enough to confirm their existence, yet too briefly to explain what they are. No name, no taxonomy, no return, only a shape, a motion, a single image framed in silence. One of the most haunting examples is a long-armed squid, a cephalopod first captured on camera by a deep-sea submersible drifting through the Gulf of Mexico. What appeared in the frame was not a typical squid. This creature had elongated, thread-like arms that stretched out in a posture unlike anything seen before. Its body hung vertically, arms outstretched below like the strings of a marionette, suspended with impossible grace. It did not flee. It did not approach. It simply hovered, as if the presence of the camera was neither threat nor interest. Then, with a single pulse, it was gone. No specimen was taken. No second sighting confirmed. The footage remains, studied endlessly, but the creature itself remains unclassified. Seen once, never again. There are others. The gulper eel, for instance, is a known but rarely observed species, an elastic-jawed predator that can inflate its throat like a balloon to consume prey nearly its own size. In one rare moment caught on film, a gulper eel was recorded mid-hunt. Its body undulated like ribbon, and as the camera approached, it opened its mouth wide, the skin stretching thin and ghost-like over its jaw. It did not attack. It simply displayed a flash of behavior that revealed more in seconds than decades of study ever could. Then it twisted and vanished into the dark. That moment remains one of the few times a species has been seen alive in action. Another encounter comes from a robotic dive over the mid-Atlantic ridge, where a translucent, flowing organism drifted into view. It was not fish or jelly, not worm or coral. Its body was delicate, almost featureless, a pale ribbon that bent and twisted in the current with no visible means of propulsion. Some speculated it was siphonophore. Others suggested a new type of larval organism, but no one could be sure. The footage showed it gliding upward for a few seconds, then coiling in on itself and vanishing behind the camera's view. That was all. A moment. A mystery. These encounters do not come with explanations. They are not followed by answers, names, or conclusions. They are fragments, glimpses of life caught in a sliver of light and pressure, then gone. They are enough to prove presence, but not enough to understand meaning. We know they exist or existed, but not what they eat, how they reproduce, where they hide, or how many there might be. In some cases, We do not even know if they were animals. There are sightings of pulsing orbs that seem to float against the current, glowing with internal light, yet reacting to nothing. There are forms that twist and spiral like seaweed, but swim in patterns far too precise. There are undulating masses that flash and vanish before sensors can lock onto them. In one expedition, a large, dark shape was recorded moving slowly across the seafloor, an outline without detail, a shadow among shadows. Its form suggested life. Its movement confirmed it. But the video ended before more could be captured. Some suggested it was a giant jellyfish, others a malformed squid, but no answer was final. These uncatchables resist study not because they are rare in number, but because of where and how they live. At depth of thousands of meters, in cold water beneath crushing pressure, traditional exploration is difficult. Submersibles are limited by time, robotics by visibility. The ocean is vast, and these creatures do not linger. They do not circle back. They appear, uninvited and unsought, then vanish as if they were never there. What makes them so compelling is not just their scarcity, but their form. Many of these beings do not resemble anything familiar. They lack the structure we expect. No clear eyes, no skeletal forms, no symmetrical limbs. They move in ways that seem improvised, driven not by muscle but by currents. They seem, at times, more fluid than flesh, shapes built for a world without gravity, without light, without pause. They remind us that we have barely scratched the surface of what lives below, that our catalogs and classifications are still young, that for every known species, there may be 10 more that live and die without ever being seen. The ocean is not just deep in space, but deep in time, holding creatures that may have evolved along paths we cannot yet understand, or perhaps not evolved much at all, existing quietly in forms that have worked for eons. Some researchers have begun to build archives of these moments, collections of unexplained encounters, fragments of footage labeled not by species, but by time and location. In the absence of names, we store coordinates. In the absence of knowledge, we preserve the image. And with each new expedition, with each new descent into black, we wait, not for confirmation, but for another glimpse. These creatures do not ask for understanding. They do not warn or welcome. They are not waiting to be caught. They are living the only way they know, in the slow pulse of the deep. Their rarity is not a trait. It is a condition, a natural result of living in a space too large to measure, too silent to disturb. And in their silence, they speak of the deep in a different language, not one of words or sounds, but of presence. They say, something is here. It may not return. It may not explain, but it is real. It moved. It lived. It left behind a single trace. In a world that often demands clarity, these uncatchables offer something else. Wonder without conclusion. Mystery without fear. A reminder that the ocean is not ours to complete, but to witness. That not every life needs to be named to be known. That some things exist just long enough to be seen, then slip back into the quiet where they belong. In the deep, where the weight of water flattens the world into stillness and the absence of light erases all color. Life does not conform to rules found on land or in the sunlit sea. Here, creatures are reduced to essentials, bare forms, minimal bones, soft flesh shaped for endurance, not elegance. There is no need for beauty or symmetry, no call for armor or grace. What thrives are the unassuming, the strange, the boneless and bristled. Among them are the polychaetes, a broad and wildly varied group of segmented worms that move like threads through the seafloor or drift in the water column like feathery ghosts. Some are long and sinuous, trailing soft bristles from their sides, sensitive to vibrations in the dark. Others glow faintly, their translucent bodies lit by bioluminescence as they swim in slow spirals. A few are predators, with ever-visible jaws that snap out from hidden sockets. Unexpected and sudden. But most are scavengers, crawling through silt, consuming decay, breathing softly in the endless quiet. Their bodies are delicate, gelatinous, adapted to the softness of mud and the stillness of deep water currents. They are not armored, not hard. They are shaped to move through darkness unnoticed. Then there is a hagfish, a creature so odd it feels fictional. Long, eel-like, and jawless, it slithers along the ocean floor searching for the scent of something dead. When it finds a carcass, often a fallen fish or the remains of a whale, it burrows inside and eats from within. It does not chew. It does not tear. It absorbs, using a rasping tongue covered in tooth-like keratin plates. Its method is slow, methodical, ancient. If threatened, the hagfish releases a cloud of slime, so dense it can clog the gills of predators. This slime expands rapidly in water, becoming a slick, suffocating defense. The hagfish then ties its body into a knot and slides a knot forward to scrape the mucus away from its own skin. There is no spine in this fish, only cartilage and persistence. It has existed in this form for over 300 million years. Brittle stars live scattered across the abyssal plains, their thin arms stretching from small central discs like the spokes of broken wheels. They are related to starfish, but more fragile, more twitching in motion. Some species move with surprising speed, bending their arms in jointed bursts across the seafloor. Others lie motionless, filtering food particles from the water or scavenging in silence. Their skeletons are not made for strength. They are delicate lattices of calcium carbonate, often barely strong enough to support their own weight. But in the deep, where there are no crashing waves or sudden impacts, this is enough. These creatures do not roar or flash. They do not glide like giants or sparkle like jellies. Instead, they persist in quiet forms, slimy, soft, simple. There is no waste in their design. They are built for survival, not spectacle. Their bodies are not meant to be seen, and in most cases, they never are. They move in the silt, in the spaces between rocks, in the folds of trenches. Their colors, if they have any, are muted, pale pinks, soft purples, translucent whites. Often, they appear colorless, drained by the absence of light and need. Many of these animals defy easy naming. New specimens are pulled from deep-sea trawls and remain unclassified for years. Their features do not match known species. Their DNA tells stories that do not fit on the existing branches of a tree of life. Some are assigned numbers. Others are kept in jars, waiting for someone to understand what they are. They do not demand attention. They wait, as they always have. There is something haunting in their simplicity. They remind us that life does not require grandeur to endure. In the most extreme places, cold, dark, and without structure, living things still find a way. Some have no eyes. Others have no defined organs. A few are little more than threads of motion, guided by chemical traces and the pull of faint currents. They are not primitive. They are refined for a specific purpose, to live where almost nothing else can. These forms challenge our sense of biology. We look for skeletons, for limbs, for intelligence measured in eyes and movement. But here, life is measured in persistence, in the ability to feed, to hide, to reproduce, slowly, infrequently, carefully. A polychaete worm might live for decades, feeding only on scattered particles. A hagfish might go months without food. A brittle star might never move more than a few meters in its lifetime. And yet, these lives are no less complete. They are full in their own way. A world of bristles, of slime, of gentle creeping over the sediment, of mouths that stretch and tongues that rasp and bodies that bend like silken water. Their rhythms are ancient. Their presence is ongoing. They do not need us to notice them. To observe them, even through a camera lens or preserved specimen, is to remember that life does not always roar. Sometimes it whispers. Sometimes it hides. Sometimes it slides quietly through mud and waits. These creatures are not broken. They are not malformed. They are not oddities. They are life in a different key, lower, slower, softer. In the deep sea, bone is a luxury. Flesh must be flexible. Energy must be conserved. And identity must be fluid. A creature might resemble many others, and yet belong to none. It might defy classification not because it is new, but because it is unchanged, because it never needed to become anything else. Bristle and bone, slime and silence. These are the shapes of survival. In the deep, these are the bodies that endure where others would dissolve. They are not always seen, but they are always there. Drifting, crawling, waiting, alive. Beneath the quiet waves and beyond the reach of light lies a landscape more vast and varied than anything on land. It is not flat, not empty. not uniform. The deep sea is sculpted with ranges and valleys, cliffs and chasms, ridges that stretch for thousands of miles, and isolated mountains that rise from the ocean floor only to remain unseen. These are the unmapped mountains below, a topography hidden by water and silence, veiled in darkness, so complete that even our most advanced maps can only guess at what lies beneath. Seamounts rise from the deep like lost continents, their peaks still submerged thousands of meters below the surface. There are tens of thousands of them scattered across the world's oceans, and the majority remain unnamed, uncharted, and unexplored, formed by volcanic activity or tectonic uplift. Some are taller than the Alps, yet invisible to satellites. Their slopes may host entire ecosystems unknown to science. Creatures adapted not just to depth, but to the unique currents and chemistry that swirl around their slopes. Around these seamounts, life gathers. Water flows differently here, deflected by rocky cliffs and ridges, creating eddies and upwellings that bring nutrients from the abyss. Corals cling to the sides of slopes that never see the sun, their colonies hundreds or thousands of years old. Strange fish drift along the currents, navigating a world shaped more by terrain than light. Some species are found only on a single seamount, never again seen elsewhere. In these isolated habitats, evolution carves out its own patterns, building creatures that exist nowhere else, fragile, rare, and often unseen. Even more mysterious are the mid-ocean ridges, vast underwater mountain chains that span the globe like hidden backbones. The Mid-Atlantic Ridge alone runs for over 10,000 miles, from the Arctic to the Southern Ocean. It is a place of creation where tectonic plates drift apart and molten rock rises to form new crust. Along its length are fissures, vents, and fault lines, sites of geothermal energy and chemical transformation. These are not quiet places. They crack and shift, belching mineral-rich fluids into the cold black, creating oases of life in otherwise barren plains. At hydrothermal vents, hot water saturated with iron, sulfur, and other elements pours into the ocean, forming towering chimneys of mineral deposits. Around them, life thrives, not fueled by sunlight, but by chemosynthesis. Bacteria convert chemicals into energy, forming the base of a food web entirely independent from the surface world. Giant tube worms, eyeless shrimp, and soft-bodied clams cluster around the vents, feeding not on each other, but on the microscopic life blooming in the mineral-rich flow. These creatures have never known the sun. They do not need it. They are sustained by the earth itself. Far below even these ridges lie the trenches, deep, narrow gashes in the seafloor where one tectonic plate slides beneath another. The Mariana Trench, the deepest of all, reaches nearly 11,000 meters below sea level. It is a place of cold and silence, of pressure so extreme it would crush any unprotected form. Yet even here, life has been found. In the deepest parts, strange amphipods scurry along the sediment. Translucent fish drift in slow arcs, and microbial mats cling to rocks like frost. These organisms live in a world that has never seen light, where the weight of the ocean presses from every direction, and yet they are not weak. They are adapted. They are alive. What makes these mountains and trenches so compelling is how little we know of them. Fewer than 20% of the world's seafloor has been mapped with high resolution. Most of our ocean maps are extrapolated from satellite readings that measure changes in sea surface height. Clues to what lies below, but not answers. The resolution is too coarse to reveal true contours. Many undersea features remain completely invisible, their existence unknown until a ship happens to pass over and record a blip in sonar. When submersibles do explore these areas, they often return with footage of life that no one has seen before. Creatures with no name, no classification, no familiar features. They cling to rock faces, hover near fissures, or drift near currents shaped by underwater cliffs. Their forms suggest ancient lineages or entirely new branches of life. Some are tiny, microscopic plankton with glassy shells. Others are large, soft, slow. They are not performing. They are simply there, as they have been for thousands of years or longer. These unmapped regions are not rare. They are the majority. The deep ocean is the least explored environment on Earth, and within it, these underwater mountains and trenches are the least explored places of all. They are too deep for divers, too vast for rovers, and too complex for current mapping technology. They are not hostile. They are just distant, hidden by depth, pressure, and silence. And yet they are full of life, full of geology, full of history. The ridges record the slow spread of continents. The vents hold clues to life's origins. The trenches bury ancient sediment that may never see the light again. To explore them is not just to look outward, but backward, into the Earth's formation, into the persistence of life, into the resilience of biology against every extreme. In many ways, these places are reminders that discovery does not always lie in the stars. That mystery is not always above us. Beneath our feet, below the waves, entire ranges of mountains stretch unseen. Entire canyons wind their way through the crust of the earth, holding life we have not yet imagined. They do not call to us. They do not need to be explored to exist, but they are there, waiting, continuing, existing in perfect silence. To think of them is to feel the scale of the planet, not in terms of distance or mass, but in terms of unknowns, in terms of wonder. Every time a submersible descends into a trench or rises along a seamount slope, it reveals something new. Not always dramatic, often small and simple, but always unique. A new coral species, a worm with unrecorded features, a chemical trace that suggests unseen biology. These moments are not rare. They are constant. Whenever we look, we find something new. And so the unmapped mountains below remain quiet, immense, and mysterious. They are not hidden by design. They are hidden by distance, by depth, by the limitations of our tools and the slowness of our curiosity. But they are not empty. They are not barren. They are rich with life that does not rise to the surface, that does not ask to be known, but that continues all the same, pulsing the dark, shaped by stone, surrounded by cold, and forever beyond the reach of casual sight. In the cold midwaters of the deep sea, suspended in the blackness between the light above and the pressure below, lives a creature whose name suggests something fearsome, but whose nature is far stranger, quieter, and more elusive than legend allows. The vampire squid, Vampirotutus infernalis, the vampire squid from hell, is not truly a squid, nor is an octopus. It is a relic, a survivor from a lineage that diverged from both long ago, an ancient hybrid, suspended in evolutionary ambiguity, with features that do not quite belong to any modern group. It is a creature that fits no clear category. It simply is. Its appearance alone suggests something otherworldly. The vampire squid's body is small, rarely exceeding 30 centimeters, with a soft, gelatinous form that flows through the water like silk. Its color shifts between deep red and black, depending on light or what little of it reaches these depths. Its eyes, disproportionately large for its body, glow with a bluish sheen, the largest eyes relative to body size in the animal kingdom. These eyes are tuned to the darkness, capable of detecting faint bioluminescence and movement in the ink-black water. Between its 8 arms is a web of dark membrane, connecting the limbs like the folds of a cloak. When threatened, the vampire squid can turn itself inside out, wrapping this cloak around its body and exposing rows of fleshy spines that give illusion of menace. But they are not sharp. They do not cut. They are soft, harmless. The creature relies not on defense through violence, but on deception and withdrawal. Its name, dramatic as it is misleading. The vampire squid does not suck blood. It does not prey on large animals. In truth, it is a scavenger, feeding on marine snow, the endless drift of organic particles that fall from the upper layers of the ocean like soft, slow rain. Bits of dead plankton, fecal matter, decaying plant fragments. This is its diet. It gathers these particles with 2 long, retractable filaments, not found in squids or octopuses, that extend far beyond its body like slender arms. These filaments are covered in tiny hairs that catch debris as it drifts down to the water column. The vampire squid then brings the particles to its beak, which is small, curved, and surprisingly delicate. It lives in the oxygen minimum zone, a layer of the ocean where the concentration of dissolved oxygen is so low that most animals cannot survive. But the vampire squid is adapted to the zone, with a low metabolic rate and blood rich in hemocyanin, a molecule that binds oxygen efficiently even in scarcity. It does not move quickly. It does not chase or flee. Its locomotion is gentle, propelled by slow pulses of its fins or subtle jetting through water. Energy is conserved, not spent. In the deep, where food is sparse and conditions are stable, this calm persistence is the key to survival. Scientifically, the vampire squid remains a puzzle. Its classification has shifted over time. Originally grouped with true squids, it was later placed into its own order, Vampiromorphida, acknowledging its unique position as a bridge between cephalopod branches. It shares traits with both squids and octopuses, but belongs fully to neither. Its internal anatomy, reproductive behavior, and embryonic development do not match any known group exactly. It is an evolutionary orphan, descended from a time when the ancestors of modern cephalopods were still finding their shapes. Unlike squids, it does not shoot ink. Instead, it releases a cloud of bioluminescent mucus filled with glowing particles that confuse and distract predators in the deep. This luminous smokescreen hangs in the water, a glowing veil behind which the vampire squid can vanish. The light is not bright. It does not dazzle. But it is strange, soft, flickering, and alien in a place where most things are dark. Reproduction is another mystery. Unlike many deep-sea cephalopods that reproduce once and die, the vampire squid appears to reproduce multiple times across its life, releasing small batches of eggs over long intervals. This slow strategy, combined with its low metabolic demands, may allow it to live longer than many of its relatives. But few individuals have been observed in the wild, and fewer still studied in controlled settings. Much of its life remains hidden. Encounters with vampire squids are rare. They do not rise to the surface. They do not gather in groups. Most sightings come from deep-sea expeditions, brief footage captured by submersibles drifting through the midwater twilight. When seen, they do not react with alarm. They pulse gently, arms trailing like ink in water, eyes watching but not revealing. There is no panic, only drift. Their world is a vast, stable layer of the sea, cold, dark, and quiet. Here, the vampire squid is perfectly at home. It does not fight the current. It exists within it, shaped by patience and subtlety. Its body is soft because it needs no armor. Its metabolism is slow because haste is not rewarded. Its light is faint because here, even a flicker is enough. To witness a vampire squid is to see something untouched by the urgency of evolution. It has not been shaped by predators or competition in the way surface creatures are. It has found a niche where simplicity endures, where being just enough is everything. And in this, there is something deeply moving. A creature that bears the name of monster, but lives as a caretaker decay. A being that appears alien, but functions with quiet grace. It is not a predator. It is not a victim. It is not even fully defined. It floats in the margins, between categories, between pressures, between lights. The vampire squid does not demand understanding. It does not explain itself, but exists as a reminder that life does not always need to fit our definitions to be real. That some creatures belong not to groups, but to time itself, unchanged, unbothered, and complete in their strangeness. In the deepest parts of the sea, far from the noise of the world, the vampire squid continues to drift, slow, ancient, and unclassified. In the deepest corners of the ocean, where pressure compacts the world into silence and time drifts like sediment, there live creatures that resist explanation. They move with jointed limbs, thin as wire, with bodies that seem too small for their legs. They resemble spiders, angular, leggy, alien, but they are not spiders. Not truly. These are the so-called sea spiders, and their existence raises a quiet, enduring problem. They do not fit. Known scientifically as pycnogonids, sea spiders are not arachnids, though they share surface-level similarities. They are marine arthropods, yes, but their relationship to better-known branches of arthropods, like insects, crustaceans, and true spiders, is still debated. Their limbs make up most of their body mass. Some have 12 legs instead of the expected 8. Many species are so thin that they seem like walking filaments. Their insides, compressed into such narrow tubes, don't follow ordinary anatomical logic. In many species, even their internal organs stretch into their legs. Some move blood, not through a robust heart, but by contracting muscles along the limbs. The gut itself extends down their appendages. They are, in many ways, creatures turned inside out. Most sea spiders are found in shallow marine environments, where they scuttle along coral or feed on soft-bodied animals like sponges. But the truly enigmatic ones live in the abyss, far below the surface, in the high-pressure blackness of the deep. Down there, sea spiders become strange in new ways. They grow to enormous sizes compared to their shallow water relatives, a phenomenon known as deep-sea gigantism. Some measure over half a meter across, their limbs reaching delicately across the seafloor, like skeletal bridges. Yet despite their size, they remain light and fragile, built for a world where every motion is slowed by pressure and distance. Their behavior is elusive. They do not hunt in the traditional sense. Many are slow feeders, inserting a long, tubular mouth into their prey and gently sucking out nutrients. Others may scavenge, but few have been observed feeding in the wild. Most of what we know about their diets comes from inference, from the shape of their mouths, the fragments found inside their digestive tracts, the types of animals in their vicinity. They have no lungs or gills. Instead, they absorb oxygen directly through their cuticle, the thin, permeable outer layer of their body. In the deep sea, where oxygen can be scarce, this method still serves them. Their bodies have adapted to such low-energy existence that even the simplest forms of respiration are sufficient. They do not move quickly. They do not waste. Reproduction is equally unusual. In most species, it is the male that carries the eggs. After mating, the female deposits her eggs onto the male's specially adapted limbs, called ovagers. He carries them through the long development process, guarding them from predators and current alike. When the young hatch, they are miniature versions of the adults, often lacking a full set of limbs at first. Over time, they molt and grow, adding legs and mass as they mature. But even with this biological knowledge, sea spiders remain difficult to place. Genetic studies yield conflicting results. Morphological comparisons offer few clear answers. Some researchers propose that sea spiders split off early in arthropod evolution, perhaps before crustaceans and insects even diverged. Others believe they belong to a distinct lineage altogether, one that simply parallels the arthropod model without sharing a common ancestor in the traditional sense. There are even arguments that sea spiders represent an entirely unique phylum, an evolutionary offshoot that mimics features we recognize, but comes from somewhere else entirely. This confusion is amplified by their appearance. Their spindly limbs and minimal bodies give the impression of something incomplete. They seem less like animals and more like the framework of animals, skeletal scaffolds animated by some slow internal logic. They do not blink or vocalize. Their senses are unknown. Their neural structure is decentralized, with no clear brain in conventional sense. What consciousness they possess, if any, is a matter of speculation. The sea spider problem, then, is not merely scientific. It is philosophical. What does it mean for a creature to exist in the spaces between our categories? To not belong neatly to any phylum or evolutionary story. The natural world has always contained anomalies. Platypuses, jellyfish, fungi, but the deep sea magnifies these anomalies into patterns. The more we explore it, the more we find animals like the sea spider. Things that look familiar but are fundamentally not. In the deep ocean, survival depends less on lineage and more on adaptation. The environment does not favor identity. It favors resilience. And so the creatures that live there often develop similar strategies, even if they come from different origins. Limbs for walking, tubes for feeding, filaments for sensing. Evolution, working in isolation, arrives at similar forms for different reasons. This is convergence. And in the deep, convergence is everywhere. Sea spiders are not rare. They're found in nearly every ocean basin. But the deep-sea varieties, those long-limbed, oversized, unclassifiable creatures, are among the least observed. Their slow-paced, delicate structure and often translucent bodies make them easy to miss, even on camera. When one appears on a submersible's feed, it moves like a shadow with purpose. It does not scurry. It drifts, legs probing the sediment, body swaying slightly with the current. It makes no sound. It leaves no trace. Their existence is not dramatic. It is persistent. They do not demand attention. They do not signal their presence. But they are there, walking across the cold floors of trenches, climbing unseen ridges, feeding quietly in the hollows of black water. They are reminders that not all life fits the diagrams. Not all animals belong to boxes we have drawn. To encounter a sea spider in the deep is to glimpse something ancient, patient, and uninterested in explanation. It is to confront a shape that seems familiar, yet escapes naming. It is to realize that our understanding of life, however broad, is still incomplete. The sea spider is not a problem to be solved. It is a question that remains. A flicker on the edge of taxonomy. A reminder that in the depths, even identity is fluid. In the vast dark of the ocean, life does not always follow the paths we expect. Sometimes it walks on long, silent legs to the unknown, perfectly content to remain unnamed. At the junction of Earth's crust, far beneath the surface and beyond the last reach of light, lie formations that seem more alien than terrestrial. Hydrothermal vents, towering mineral chimneys that spew scalding fluids into the frigid ocean depths. These vents rise like blackened spires from the seafloor, surrounded by shimmering clouds of mineral-rich water, glowing faintly with heat in a world otherwise ruled by cold. In these extreme conditions, where pressure would crush, darkness blinds, and temperatures swing violently, life not only survives, but flourishes in astonishing, unthinkable forms. This is one of the rarest ecosystems on Earth, a place without sunlight, where biology is fueled not by photosynthesis, but by chemosynthesis. Instead of plants capturing energy from the sun, bacteria here capture energy from chemicals, primarily hydrogen sulfide, vented from beneath the seafloor. These microscopic organisms form the foundation of an entire food web, one unlike anything else on Earth's surface. Around the base of the vents, nestled in the folds of hardening mineral, live tube worms, tall, bright white stalks with crimson plumes. These are not plants. They are animals, yet they possess no mouths, no digestive systems, and no apparent means of feeding. They survive through symbiosis. Inside their bodies live specialized bacteria that convert the sulfides from vent water into usable energy. In return, the worm provides the bacteria with a stable home, a supply of chemicals, and access to the vent flow. Together, they form a single system, neither one truly complete without the other. The worm becomes a vessel for life that would otherwise be impossible. Some tube worm colonies stretch for meters in height and extend across the seafloor in dense groves, forming towering forests in the dark. These creatures live for decades, possibly centuries. Their growth is slow, deliberate, and sustained entirely by the invisible chemistry of the deep. They anchor themselves to mineral base, unmoving, their red plumes extending into the current like underwater flowers, drawing in sulfide-rich water not for themselves, but for their internal symbionts. Nearby, giant clams rest half-buried in sediment, their thick shells parted just enough to reveal the soft tissue within. Like the tube worms, these clams possess no functioning digestive system. Instead, they too harbor bacteria within their gills that process chemicals into nutrients. They are heavy, dense with calcium carbonate, and often live in large aggregations, blanketing the vent fields in pale shells that click and shift in the current. They do not feed in any recognizable way. They live, instead, as homes for bacteria, and in doing so, become life themselves. Other animals drift nearby. Eyeless shrimp with reflective patches, instead of vision, squat lobsters with tiny claws adapted to pluck particles from the water, and strange fish with flattened heads and slow, sweeping tails. Many are pale, some translucent, their pigmentation faded from generations in darkness. Some of the shrimp crowd directly around the hottest parts of the vents, their bodies pressed perilously close to superheated water. They feed not on other animals, but on the thin microbial mats that grow along the vent surfaces. Tiny communities of chemosynthetic life that paint the rock in thin films of colorless texture. The heat of the vent water can reach over 400 degrees Celsius, but because it is released into near-freezing ocean, it cools rapidly into visible plumes, clouds of chemical mist that rise into blackness above. These plumes are rich with minerals, iron, manganese, sulfur, and create a chemical soup in which this entire web of life is suspended. The animals that live here have evolved to detect and respond to tiny shifts in that chemical balance. Their bodies are tuned not to light or color, but to acidity, temperature, and sulfur concentration. Bacteria are not just the base of the food web. They are the architects of the ecosystem. Some form biofilms that coat the rock, while others drift free in the vent plume. A few even live inside the very tissues of vent animals, shaping their evolution from within. This form of symbiosis is not rare here. It is the rule. Nearly every life form of the vent relies on bacteria to survive, and often carries them within its body. In many ways, these creatures are not individual organisms, but partnerships, hybrid forms that straddle a line between microbe and animal. The result is an ecosystem that looks and functions unlike any other. There is no sunlight. There is no plant life. Yet the region teems with life. Dense, strange, vibrant in ways that challenge our understanding of biology. It is not the abundance that surprises, but the creativity. Worms that feed without mouths. Clams that digest with their gills. Shrimp that see without eyes. Every feature here has evolved to meet a challenge foreign to surface life. Discovery of hydrothermal vents in the late 1970s changed the way scientists viewed the conditions necessary for life. Until then, it was widely believed that sunlight was a primary energy source for all ecosystems. The vents proved otherwise. Here, in the most lightless parts of the ocean, life thrived, not despite the absence of light, but because it found another way. A way powered by the heat and chemicals of Earth itself. The implications ripple far beyond the ocean floor. If life can arise in such extreme, lightless environments, it may also exist in similar conditions elsewhere, on icy moons like Europa or Enceladus, where liquid oceans lie beneath frozen crusts and geothermal energy may stir the dark waters. The vent suggests that life does not need warmth or daylight. It needs chemistry, stability, and time. In the stillness of deep pressure and darkness, it can bloom quietly. But these vent communities are fragile. Their locations are patchy, small oases scattered across an enormous seafloor. A single vent field may be separated by hundreds of kilometers from its nearest neighbor. If one vent cools or collapses, the animals that depend on it may die without migrating to another site. Their larvae float in the water column, searching by chemical cues for suitable places to settle, a task made more difficult by the vast emptiness between vents. Despite their resilience to pressure and heat, these ecosystems are vulnerable to human disruption. Deep-sea mining threatens to destroy the chimneys and terrain where vent life clings. Even scientific exploration, if not done carefully, can alter the balance of chemicals or crush fragile animals under the weight of submersibles. What has taken thousands of years to grow can be lost in a moment, and yet the vents endure. Many are still undiscovered, their heat signatures faint and unexplored. Others rise anew as tectonic plates shift, opening fresh cracks in the crust and releasing mineral-rich water into the sea. Each new vent is a chance for new life to take hold, a blank canvas for bacteria to settle, for worms to anchor, for shrimp to gather. The process begins again, slowly, quietly, beautifully. To stand, or rather, to float, near one of these vents is to witness the earth breathing. It is to see life not in its familiar forms, but in possibilities. Shapes that bend expectation. Systems that ignore the need for light. Creatures that challenge what it means to be alive. There is no sun here. No day or night. No seasons. Only pressure, chemistry, and life. Life that does not ask to be known. That does not rise to meet us. That continues, softly, because it can, because it always has. And because, even in the darkest places, there is warmth, there is energy, there is life. Every so often, the sea returns something strange to the land. Not a shell or a fish, but something vast, formless, and unclassifiable. A creature, perhaps, or the remains of one. These are the blobs, massive, gelatinous shapes that wash up on beaches without warning, shapeless heaps of flesh and sinew that defy explanation. They appear as if pulled from dreams or legends, creatures that seem more myth than biology. And yet they are real, photographed and studied, puzzled over and debated, then quietly forgotten, left to dissolve back into the sand, unsolved. These so-called blobs are not singular. They have appeared in many places and times. From the Pacific coast of North America to the shores of New Zealand, South America, and the Philippines, beachgoers and fishermen have stumbled across their hulking forms. Pale, decaying, and alien in every sense. Often, they are accompanied by a sour stench, the scent of marine decay mingled with salt and age. The texture is usually soft, fibrous, almost rubbery. Hair-like strands sometimes cling to the surface. No clear head or limbs are visible. No recognizable anatomy reveals what they once were. In 1896, one of the first documented blobs washed ashore in St. Augustine, Florida. It was described as enormous, over 6 meters long, and made of a silvery, fibrous substance. Locals speculated it might be the remains of a giant octopus, a sea monster, or something altogether new. Photographs and tissue samples were taken, though analysis at the time was limited. It would be decades before scientists could attempt to classify it, and even then, no consensus was reached. Other blobs followed. In 1960, a massive, unidentifiable carcass was found in Tasmania. In 1977, the famous New Zealand globster was discovered. Its body decomposed beyond recognition. It too lacked bones or visible organs, appearing instead as a flattened, white mass tangled in what seemed like cartilage or collagen. In 1990, another blob appeared in Bermuda, its outer layer riddled with what looked like tube-like structures. Each new discovery brought with it a mix of curiosity and discomfort, a sense that something enormous and unknown had drifted from the deep. Theories abound. Some scientists have suggested that most blobs are the decaying remains of known animals, particularly whales or basking sharks, whose bodies have been altered by time, current, and scavengers. As these creatures decompose, soft tissues break down at different rates. Muscles, skin, and fat dissolve, while fibrous connective tissues remain, giving the appearance of formless mass. Without bones or familiar structure, these remnants can seem entirely alien. Others argue that the structure of many blobs is too distinct to be written off as decay. Some display symmetry, hinting at tentacles or fins. Others are composed of unknown tissues that resist easy comparison. DNA testing, when possible, has sometimes offered clarity. In a few cases, it is confirmed that the blob in question was indeed from a whale or a large fish. But in other instances, the samples yield ambiguous results, degraded by salt water in time or contaminated beyond usability. Part of what makes blobs so mysterious is their location. They come from the deep, dragged ashore by storms, currents, or death, but the exact place of origin is impossible to trace. The ocean is vast, and these bodies drift. By the time they reach land, they have been transformed. Bones may have sunk, flesh may have bloated or liquefied. What arrives is only a remnant, a distorted echo of the living form. To see one in person is to be confronted with scale. Some stretch for meters, others weigh several tons. Their mass is not just biological, it is symbolic. They represent something larger than themselves, the unknown, a creature too large to identify, too shapeless to catalog, too unfamiliar to name. In a world increasingly mapped and measured, they are reminders that not everything has been brought into light. Culturally, blobs have fueled folklore and speculation. Some see them as proof of sea monsters, survivors of prehistoric eras, or undiscovered giants of the abyss. The mind, when faced with the unexplainable, often turns to stories. A tentacled beast, long dead, risen from the trenches. A whale so ancient its species no longer exists. An alien visitor from beneath the crust of the ocean, broken apart by pressure and time. These are not scientific theories, but they persist because the ocean invites such imagination. In the absence of evidence, the unknown expands. The blob becomes a canvas. For some, it is merely a puzzle. For others, a possibility. In reality, the answer may lie somewhere in between. Not all blobs are unknown species, but not all can be easily explained away. The sea is filled with creatures we barely understand. Some live far deeper than we can dive. Others appear only in certain seasons, or die before reaching adulthood, leaving no trace behind. What matters most, perhaps, is not the exact nature of each blob, but what they reveal about the ocean itself. They are physical proof that the deep still keeps secrets. that not all of its inhabitants leave behind bones or fossils, that some forms of life do not conform to our need for clarity. They are fragments of conversation the ocean is having with itself, slow, cold, and indifferent to our interpretation. When the tide rises again, most blobs are taken back. The sea reclaims them, erasing whatever clues might have remained. And the beach is left clean as though nothing had happened. But the memory lingers, the shape, the texture, the unanswered question. For a moment, the deep sent something to the surface. It did not explain. It did not wait. It simply arrived, then returned. To think of these washed-up forms is to think of everything that lives just beyond reach, of the beings that rise and fall without notice, of the mass and mystery that move in silence beneath the waves. They are not monsters. They are not miracles. They are simply unknown. And in the unknown, there is always room for wonder. Just beyond the sunlit world, where the ocean begins to steep itself in blue shadows and light gives way to darkness, lies a region known as the continental slope, a steep descent that connects the shallow continental shelf to the vast abyssal plain below. Here, in the twilight zone between 200 and 1,000 meters deep, the last glimmers of sunlight flicker and fade. It is a world in transition, where pressure begins to rise, temperatures drop, and light is no longer a constant, but a flickering memory. Within this descending gradient, life changes shape, becoming more transparent, more delicate, more like a ghost than a body. These are the ghouls of the continental slope, creatures that seem barely real, with bodies too soft to touch, too thin to hold, and anatomies that defy simple explanation. Many of these beings appear as if sculpted from glass or jelly. They drift, often motionless, suspended in layers of cold water, their bodies barely distinguishable from the darkness around them. Some are nearly invisible, entire organisms constructed from tissues so transparent they seem like apparitions. Ribs, spines, and organs float within them like pale threads, faintly outlined by bioluminescence or backlit by passing submersibles. Their structure is minimal, almost provisional, as if nature was still in the process of deciding what shape they should take. One such creature is a glass squid, whose mantle is almost entirely see-through. Its internal organs are faintly visible inside its soft dome, and its eyes shimmer like coins beneath ice. It does not dart like its shallow water cousins. It pulses slowly, cautiously, conserving energy in a zone where food is scarce and motion is costly. When threatened, it glows, not brightly, but with a gentle internal light, diffused through its body like a lantern buried in fog. Then it disappears again, fading into the dimness as if it were never there. The barrel-eyed fish is another ghost of this slope. It has a transparent, dome-shaped head, through which its large, tubular eyes can be seen pointing upward. These eyes, encased in fluid, are capable of detecting the silhouettes of prey above. Beneath the dome, its internal structures are visible: brain, muscle, nerve. Nothing is hidden. Its entire head is like a window into its biology, a strange and fragile arrangement that seems almost unreal. It hovers motionless in the water, eyes tilted skyward, waiting for something to drift down: jellyfish, plankton, whatever the twilight will deliver. Then there are the pelican eels with enormous jaws and thin, whip-like tails. Their bodies are soft and loose, lacking the firm musculature of typical fish. They open their mouths wide, wider than their bodies, revealing cavernous voids that can trap prey much larger than expected. Once full, the mouth collapses again into a narrow silhouette, and the eel drifts onward. No fast pursuit, just expansion, capture, and silence. Skeleton shrimp also haunt these slopes, tiny, transparent crustaceans that cling to seaweed and hydroids within hook-like limbs. Their bodies are elongated and almost invisible, their legs moving in slow, deliberate arcs. They're not truly skeletal, but their shape evokes that word: thin, hollow, essential. They live in colonies, crawling over each other like slow shadows, barely seen. Some jellyfish species that drift here take on lace-like forms, their tissues stretch into webs of light and motion. Others resemble nothing more than glowing bubbles, orb-like medusae with slow-beating bells, and nearly non-existent musculature. There are siphonophores that stretch for meters, each section a specialized part of the whole, glowing gently as they drift in long, pulsing chains. They too look skeletal in form, like a spine of drifting light. Many of these creatures have reduced or absent pigmentation. They do not need color, because there is no light to reflect it. Their bones, when they exist at all, are thin and flexible. Their tissues are often gelatinous, containing high levels of water and few supportive structures. These adaptations allow them to withstand pressure without collapsing, to move without using much energy, and to float with neutral buoyancy in a world that punishes weight. Some have bodies so soft that nets cannot retrieve them intact. When collected, they fall apart, dissolving into fragments, becoming unrecognizable. This has made studying them difficult. What we know comes mostly from footage, glimpses through deep-sea cameras, and the rare specimens that survive collection. Their behavior, life cycles, and even diet are still mysteries. The physiology of these creatures seems designed not for living, but for lingering, for occupying space without touching it too firmly. They're suspended between worlds, not fully the surface, yet not quite part of the abyss. They belong to a realm in flux, where pressure and light are in constant negotiation, and where the shapes of life are allowed to stretch, blur, and fade. To encounter one of these animals is to question what life requires. Bones? Muscles? Color? Solidity? The ghouls of the continental slope suggest otherwise. Life here is minimal. It is presence without weight. It is movement without structure. It is biology reduced to its faintest outline, a breath held just below the threshold of being. They do not roar or glow in spectacle. They flicker. They drift. They dissolve when grasped. And in this, there is something profound. These creatures are not failed versions of the robust animals above. They are successful in ways we do not fully understand. They endure without armor. They feed without jaws. They swim without fins. They are complete in their softness, efficient in their transparency, perfect in their impermanence. As the slope descends and twilight deepens into darkness, these ghouls give way to the harder forms of the abyss. Creatures adapted to even greater pressure, colder temperatures, deeper silence. But in this in-between place, the edge of light, the ghosts still linger. They move slowly, bones barely holding them together. Jelly giving way to motion, eyes staring upward through their own skulls. They are real. They are alive. And they are watching, as they have for thousands of years, from just beyond the reach of light, in the great dark beneath the ocean's surface, where human bodies cannot go and light does not reach. Our eyes are mechanical. Robotic submersibles, ROVs, or remotely operated vehicles descend into the deep, trailing cables, blinking lights, and quiet cameras. They drift through water denser than air, recording what lies below with silent patience. Through their lenses, we have glimpsed a world that speaks not in color or sound, but in motion, in form, in shadow. These encounters are often brief, sometimes distorted, always strange. The deep does not perform for our machines. But now and then, something passes through the frame, something unidentifiable, unrepeatable, and unforgettable. It begins with a flicker. A shape moves in the distance, its edges soft and indistinct. The ROV turns, slowly adjusting its course, the propellers humming as it orients itself toward the anomaly. There, in the narrow beam of its lights, a figure appears. Sometimes it is small, an orb, pulsing softly, translucent and glowing. Sometimes it is large, so large that only part of it is visible on the screen, a curve of flesh, a sweep of tentacle, a slow-moving shadow that refuses to show its whole form. These moments are not planned. The deep sea does not yield to schedules. Many encounters occur when the ROV is traveling between designated research sites, passing through featureless terrain. It is in these empty stretches, far from vents or known habitats, that the most inexplicable shapes appear. Some seem to float without direction, carried by currents that cannot be felt. Others move with purpose, angles shifting in ways that suggest awareness, but not familiarity. One of the most iconic sightings involved a long, twisting organism with delicate fins and a translucent body that seemed to unfold in waves. The ROV's camera followed it for nearly 5 minutes as it spiraled upward, revealing a body unlike any known eel or fish. There were no visible eyes, no mouth, just soft movement and an impossibly long thread trailing behind. When scientists reviewed the footage, They could not identify it. No classification matched. It was added to a growing archive, marked a number, a timestamp, a depth. Seen once, never again. Another ROV recorded a pulsing orb, perfectly spherical, about the size of a grapefruit, floating mid-water with no visible means of propulsion. Its surface shimmered faintly, and inside it, something rotated. The sphere did not rise or fall. It held its position, undisturbed by the machine's approach. When the ROV extended its manipulator arm, the orb responded, not by fleeing, but by dimming. The light faded slowly from within until the sphere was no longer visible. When the lights were turned off and then back on, it was gone. Many encounters are with things even less defined. Blobs of gelatinous matter that pulse once, then drift out of view. Tangles of what appear to be tendrils or filaments, waving with no apparent body. Web-like structures suspended in water, breaking apart as the ROV draws near. These forms do not register on sonar. They do not reflect light, as solid bodies do. They seem to exist on the threshold of perception. Almost there, but not quite. Then there are the shadows. The deep is full of them. Some are tricks of light, reflections from the ROV's own beams bouncing off particles in the water. But some are not. Some move independently, with a smoothness that suggests muscle. A shape passes near the camera, enormous, unstructured, disappearing before its form can be resolved. A tentacle? A fin? A body so large it cannot be captured in a single frame? The footage is reviewed again and again, but the answers remain elusive. Scientists who operate these vehicles often describe the feeling of watching screens during a dive. Hours of nothing. Then, suddenly a flicker. Everyone leans forward. What is it? The lights adjust. The ROV shifts. There's a moment, perhaps 3 seconds, when something wholly new appears. No one speaks. Then it's gone. The crew is left blinking at the monitor, scrolling back through the frames, replaying the movement over and over in slow motion. Not all sightings are terrifying or strange in form. Some are beautiful. A jellyfish with rings of bioluminescence pulsing along its bell like concentric circles. A ribbon-like creature trailing light in arcs behind it. A soft-bodied animal that seems to fold and unfold itself as it swims. Many of these creatures are unnamed. Some are never seen again. They are part of the deep's vocabulary, a language spoken in glimpses. The problem, always, is that the footage is limited. Cameras capture only what passes directly in front of them, often in narrow cones of visibility. The deep is vast. Most of what swims or never enters our field of view. And what does may only appear briefly, from one angle, under artificial light that distorts color and scale. Without specimens, without full views, classification is guesswork. We record, we archive, but we do not always understand. There are catalogs now, databases of unidentified midwater organisms, each assigned a code, a description, a depth, and location. Scientists revisit these clips regularly, hoping to find matches, patterns, similarities. Sometimes they succeed. A creature seen in the Atlantic reappears years later in the Pacific. Other times, a shape recorded once is never seen again. These entries remain open-ended, suspended in the gray zone between discovery and mystery. Some ROV encounters suggest not just new species, but entirely new forms of life, organisms that defy known categories. A creature with no symmetry, no segmentation, no clear organs. A mass that changes shape as it moves. A form that appears solid from one angle and transparent from another. The more we explore, the more we realize that the ocean has not finished surprising us. To watch these moments is to experience a kind of quiet awe. There is no narration, no music, no dramatic revelation. Just silence, hum, light, and movement. A creature passes. The camera follows. Then silence again. The deep offers nothing more. It does not explain itself. And perhaps that is what makes these encounters so powerful. They are not staged. They are not sought. They simply happen, caught by machines we have lowered into the dark. They remind us that the ocean is not just unknown. It is unknowable in parts. That its life does not wait for us to find it. That mystery is not a question to be answered, but a presence to be felt. In the end, the footage returns to the surface. The tapes are stored. The data is labeled. Another dive begins. The ROV descends once more, lights flickering against the black. Cameras rolling, arms extended. Waiting, watching, listening for the next shape, the next flicker, the next ghost to drift through the lens. In the deep places of the ocean, far beneath the currents and beyond the bounds of light, there exists beings so strange they seem not just alien, but impossible. They drift, roll, flatten, and billow like fabric in slow water, their bodies formed of near transparency and motion. They are not fish. They are not insects. They are not even clearly animals, in the sense most understand. They are the unclassifiable jellies, creatures so rare and so unlike anything known that they defy the language of taxonomy. Some of them, like the deep styria, have been seen only a handful of times. When one appears, it moves not with pulses, but with undulations. It's massive, umbrella-like bell flowing like silk in a silent current. Its body is soft, membranous, and nearly invisible until lit by the beam of a submersible. Once illuminated, the folds of its tissue reveal an internal webbing, a faintly geometric mesh that expands and contracts with each movement. It is not clear where its mouth is. It is not clear where it begins or ends. Sometimes it seems to envelop things, debris, small fish, plankton, but what happens after is unknown. Others are even stranger. The ghost medusa, Stygia medusa gigantea, is among the rarest of jelly-like creatures ever filmed. Its appearance is ghostly in every sense. With a bell that can span over 1.4 meters long, veil-like arms that trail behind it like banners, it moves with a haunting grace. No stinging tentacles are visible, no propulsion obvious. Its motion is slow and effortless, as if the water itself is carrying it. Most sightings last only seconds. The ghost medusa drifts into frame, hovers, and fades into darkness, one of the deep's most mysterious apparitions. Then there are the creatures that appear only once and never again. One such jelly was recorded spiraling like a ribbon in the Gulf of Mexico, its body twisted in a double helix, trailing luminous filaments that shimmered as they spiraled. Scientists watched, baffled. No known species matched the form. It had no recognizable bell, no arms, no visible anatomy. It moved with elegance, but offered no clues. After 2 minutes, it spun out of sight and has not been seen since. Many of these jellies belong to groups only partially understood. Ctenophores, siphonophores, medusae, or something else entirely. Their forms blur the lines between known classifications. Some pulse with rows of tiny cilia, beating light into the water like a living rainbow. Others emit soft blue glows from internal chambers, lighting up the dark with bioluminescence that seems to flicker from within. Some have internal canals. Others are essentially hollow. Their bodies may contain more than 95% water, yet they move with precision. They hunt, feed, reproduce, and drift through the abyss like soft machines sculpted by pressure and time. What makes these creatures unclassifiable is not just their rarity or beauty, but their lack of fixed structure. Unlike fish, which follow clear blueprint of spine, gill, fin, and eye, these jellies seem to rewrite their shape as they move. Some expand and contract like parachutes. Others fold themselves into spirals. A few flatten into discs or stretch out into flowing sheets. Their organs, if present, are rudimentary. Their nervous systems are diffuse. Many have no brain at all. And yet they survive. They find food. They navigate currents. Some reproduce by cloning, others by releasing clouds of eggs and sperm into water, trusting chance and chemistry to continue their line. Their fragility is a form of resilience. Their transparency is protection. In the deep, where predators hunt by light and shape, being invisible is the ultimate defense. Because of their softness, most of these jellies cannot be collected. Nets destroy them. Pressure change bursts them. Even the suction of submersible arms can reduce them to formless gel. What we know of them comes almost entirely from video footage. Fragments of film in which a shape drifts by, glows, turns, and vanishes. These videos are cataloged, numbered, archived with names like Unidentified Medusa 2020-2004 or Deep Spiral 2016. Each is studied, debated, and eventually filed under mystery. It's not that scientists don't want to classify them. It's that the criteria do not apply. What is a species when its anatomy is unclear? What is an organism when its parts seem to blur into one another? In some cases, researchers cannot even determine if they are seeing one animal or a colony. Some siphonophores, for example, appear as single beings but are actually collectives of many specialized units working together: swimmers, feeders, breeders, all genetically identical, all functioning as one. Encounters with these jellies feel more like dreams and discoveries. They pass through the lights of our machines with no sign of recognition, no response. Their movement is neither curious nor fearful. It is uninterrupted. They do not react. They do not flee. They continue on as if the camera is not there. And in many ways, it isn't not to them. These are creatures built for solitude, for pressure, for silence. There's an eerie peace in watching them. The way their bodies fold and flex. The way their light flickers in patterns that seem to speak a language without sound. They do not reveal themselves all at once. They suggest. A shadow becomes a ripple becomes a glow becomes a jelly. Then it disappears, and the water returns to black. For every jelly we've documented, there are likely dozens we have not. The ocean is vast, and our eyes, our cameras, see only in narrow cones, for short hours, in small corners of a world that stretches without end. Most of these creatures live far below the reach of casual observation. Some may appear only during certain seasons. Others may live their entire lives in drifting loops, never rising near the surface, never encountering a lens. To call them unclassifiable is not to deny their place in nature, but to acknowledge our limits. These are lives that do not conform to the outlines we've drawn. They exist without needing to fit. They do not ask to be understood. They are complete in their own strangeness. They have evolved, adapted, and persisted, not to be studied, but simply to be. And perhaps that's the lesson they offer. That life can be soft, slow, and shapeless, and still succeed. That the boundaries we set between animal, colony, and motion blur under enough pressure. That the deep, in all its darkness, holds forms we were never meant to explain. The unclassifiable jellies continue to drift through that dark. Some may be passing now, just beyond the reach of our sensors, their bodies folding and glowing in quiet solitude. One day, perhaps, they will pass again through a camera's light, and we will record them, number them, study their frames. But we may never name them, and that is enough. In the silent dark of the deep sea, where no sunlight penetrates and the world is shaped by shadow, life has found remarkable ways to see, not with vision as we know it, not with color or detail or brightness, but with adaptation so strange, so precise, and so foreign to human understanding that they seem drawn from science fiction rather than biology. These are the eyes of the abyss, telescoping, mirrored, layered, glowing. Eyes that do not look, but sense. Eyes that catch the faintest whispers of light, the barest traces of bioluminescence flickering across black water. Eyes like no other. At these depths, vision becomes paradoxical. There is no sunlight, and yet vision matters more than ever. Most deep-sea creatures cannot rely on touch, sound, or scent alone. They must spot movement, identify food, locate mates, or evade predators, all in darkness. So their eyes have evolved not to see everything, but to see only what matters. A single flicker, a subtle glow, a shape shifting against a field of black. Their vision is not broad. It is precise. One of the most extraordinary adaptations is found in the barrel-eye fish. From above, its face looks featureless, but translucent dome at the top of its head reveals what lies beneath. Two large barrel-shaped eyes that point upward, encased in fluid, glowing green beneath the curved shield of its skull. These tubular eyes are like periscopes, adapted to detect the silhouettes of prey above. The lens and retina are aligned in a vertical tunnel, allowing maximum light collection in a narrow direction. These eyes can rotate within the dome, scanning upward with mechanical precision. They do not see sideways. They do not see downward. They see one thing in one direction, and they do it perfectly. Other creatures have taken different paths. The spookfish, for example, has developed a kind of eye never seen in vertebrates on land, a mirror eye. Instead of relying solely on a lens to focus light, the spookfish uses a curved mirror of reflective crystals located within a secondary chamber. Light enters the main eye and is split. Some is focused by the lens, and some by the mirror. This gives the fish two overlapping fields of vision, one for light coming from above, and one from below. In an environment where light comes only from fleeting flashes, this dual system increases the chances of detecting movement from any direction. Then there are animals with layered retinas, multiple tiers of light-sensitive cells stacked like floors in a building. The brown snout spookfish, for instance, is thought to possess 3 distinct retinal layers, each optimized for a different angle or intensity of light. This is not vision in the sense of color or clarity. It is stratified detection, different depths of sensitivity, tuned to the faintest photon. In this architecture, even the smallest flicker becomes a signal. The hatchetfish, a small, silvery predator with upward-facing eyes, also demonstrates how precise deep-sea vision can be. Its eyes are enormous in proportion to its body, with lenses that allow it to detect the outlines of animals swimming above. Its entire head is structured around the eyes, like twin satellite dishes tuned to a single direction. The fish itself glows with bioluminescent spots along its belly, counterillumination that masks its silhouette from predators below. It becomes invisible from beneath and hypervisual from above, a creature adapted for both hiding and seeing. Some species do not have eyes in traditional sense at all, but light-detecting patches or pits. Others, like certain squid, possess one eye that is significantly larger than the other. This asymmetry is not a deformity. It is a design. The larger eye faces upward, detecting dim light from the surface or bioluminescent prey. The smaller eye faces downward, watching for movement in the pitch-black depths. Each eye serves a different purpose, and together they form a visual system optimized for a three-dimensional world where darkness is not uniform. Bioluminescence plays a crucial role in these ecosystems, and many deep-sea eyes are adapted to detect specific wavelengths of blue or green, the most common hues of underwater glow. Some creatures, like the dragonfish, produce and detect red bioluminescence, which most prey cannot see. This gives them a form of deep-sea night vision, illuminating targets that remain unaware of being seen. The dragonfish's eyes are sensitive to red light, but its own body emits a faint red beam from a photophore near its mouth. It can shine light into the dark and see without being seen. The retina structures in these animals are highly specialized. Rod cells dominate. Photoreceptors designed to collect as much light as possible, sacrificing color for sensitivity. Cone cells, which allow for color vision, are often absent or minimal. In their place are rods stacked densely, sometimes even layered, to multiply the amount of information gathered from the faintest glow. In some species, the eyes appear silver or reflective from the outside, a mirror-like coating that increases internal reflection, bouncing light back to the retina to give it a second chance at detection. And yet, not all deep-sea vision is about enhancement. Some creatures embrace blindness. In environments where even bioluminescence is rare, where food is scarce and light non-existent, some animals forego eyes entirely. These include certain deep-sea worms, crustaceans, and fish species. Instead of visual systems, they develop enhanced pressure sensors, chemical detectors, or long antennae. Evolution takes no sides. It gives what is needed and removes what is not. Eyes, though complex, are not sacred. In total darkness, they become unnecessary. But for those that do see, vision becomes something else. Something not just mechanical, but almost intuitive. These creatures do not watch. They sense. They interpret subtle shifts in brightness, the trail of a glowing lure, the faint bloom of a distant photophore. Vision here is not about scenery or shape. It is about presence. Something is there. Something moved. Something glowed. That is enough. The variety of visual adaptations found in the deep sea reminds us how plastic and powerful evolution can be. Faced with the challenge of total darkness, life does not give up. It invents. It shapes new tools. It bends the rules. The result is not one solution, but many. Eyes that tunnel, eyes that mirror, eyes that filter, and eyes that glow. To study these eyes is to see the ocean not just as a place, but as an environment with its own language of sight. Light is rare, but not absent. Movement is subtle, but crucial. Shapes are soft, and edges dissolve. Eyes like no other have emerged to make sense of this world. Not to see in full, but to see what matters. And somewhere now, in the deep, a barrel eye hovers, eyes tilted upward inside its transparent dome. A dragonfish glows faint red. A jelly pulses with rings of light. And many others, never yet seen, drift quietly in the dark, watching, always watching, through eyes we do not yet understand. In the deepest layers of the ocean, where even machines hesitate to linger and light dissolves into nothing, stories emerge, not of monsters or myths, but of something more subtle, more unnerving. Shadows, moving, living shadows, not quite seen, not quite explained, but felt, witnessed, known, in the way one knows they're being watched in the dark. These are not the dramatic sea serpents of old sailors' tales, nor the known shapes of squid, whales, or sharks. These are anomalies, massive, deliberate shapes that pass through the water without effort or noise, leaving behind silence, questions, and a distinct impression of presence. Most of these accounts come not from fanciful legends, but from modern explorers, divers, deep-sea submersible pilots, and robotic camera operators. The first sign is often movement at the edge of vision, a shift in the water. A light source dims slightly, not because it fails, but because something has passed in front of it. The shape is too large to grasp in a single frame. It might take several seconds to cross the field of view, but there are no clear lines, no fins, no eyes, just a silhouette, a form darker than the dark it moves through. Some submersible pilots report sensations of scale, a pressure not physical, but psychological, a feeling that the craft is no longer alone. Sometimes sonar will register nothing. Other times, it will ping a return so large and vague that it's dismissed as error, interference, or terrain. But then the shape moves, not as a mass of particles or a school of fish, but as a single cohesive entity, a living shadow. One ROV team exploring a trench off the coast of Japan recorded footage of such an event. The vehicle was stationed near a hydrothermal vent, collecting readings when the lights flickered slightly. Then, something crossed the screen. It was not fast. It moved with the deliberate calm of a drifting glacier. For nearly 30 seconds, the camera was engulfed in darkness. Not failure, not malfunction, just black. When the light returned, the environment was unchanged. But for those who watched live, the feeling lingered, a moment of being in the presence of something immense, silent, and unknown. Divers in shallower regions have also told stories, though always with hesitance. Many are seasoned professionals, scientists, biologists, engineers, not prone to exaggeration, and yet they describe moments underwater when visibility dropped. Not because of silt, current, or cloud, but because something passed between them and the light. A dark shape, soundless and slow, moving just beyond reach. When pursued, it would not flee. It would simply fade into the surrounding dark, like smoke dispersing in air. What could these shadows be? Theories range widely. Some believe they are undiscovered species of colossal invertebrates, perhaps a new class of cephalopod, large and soft-bodied, adapted for extreme depths. Others speculate on ancient vertebrates, perhaps relatives of known species that have grown beyond expectations in isolation. Some suggest these are not animals at all, but vast colonies, organisms made up of many coordinated parts, moving as one. There is even a suggestion that some of these shadows are not truly biological, but structural, made of living tissue but behaving more like terrain. A kind of drifting reef or gelatinous plateau, evolved not to swim or hunt, but simply to float, feed, and pass. These ideas remain unproven, but they reflect the reality that in the deep ocean, form often follows no rules. Survival does not require symmetry, limbs, or even definition. Part of what makes these sightings so eerie is their restraint. These shadows do not attack. They do not pursue. They do not interact. They move through the water with a patience that feels almost ancient. Unconcerned with the lights and probes we send to find them, they are not aggressive, but they are not indifferent either. Their motion is too specific. Their timing, too precise. They pass when watched. They vanish when pursued. Their behavior is not chaotic. It is quiet, deliberate, observant. In a few rare cases, these shadows have reportedly responded to sound. Submersibles using sonar or mechanical arms have noted sudden decreases in visibility, as if a wall of dark matter approached. But again, no contact was made. No harm, only presence. A mass arrived, loomed, and left. The recordings we have are inconclusive. Most are partial frames. Flickers, light distortion, brief silhouettes. It is difficult to capture a shadow that doesn't want to be seen. Still, researchers catalog these anomalies. Large unidentified object. Dark mass, unknown structure. Slow-moving, low-reflectivity entity. Each file is marked, dated, archived. A growing record of that which we almost see. It is tempting to assign meaning to these encounters, to call them sentient or ancient or alien. But the truth may be simpler. The deep ocean is vast beyond comprehension. Pressure shapes its life in ways we are only beginning to understand. What we call shadows may simply be creatures evolved to slip between perception and analysis, not mysterious by intention, but by nature. Yet, there is something the way these shadows move, the way they avoid the full frame, the way they seem to know, somehow, the limits of our sensors. It may be coincidence, or it may be design. The living shadow remains a phenomenon of half-knowledge. We see the edge, we glimpse the curve, we feel the weight of its passing, but we do not hold it, we do not know it, and maybe we never will. Still, they drift there below, in the cold layers beyond sight, moving, watching, unnamed, alive, beneath the crushing weight of the deep sea, far past the reach of light. Where silence thickens into something nearly physical, the seafloor begins to resemble a kind of alien forest, not of trees or undergrowth as we know them, but of animals, living forms rooted to ground, swaying, breathing, pulsing softly in the cold currents. These are the animal forests, vast and ancient, composed not of plants but of creatures, tube worms, sponges, corals, and other forms that defy the usual categories of life. They grow in silence, stretch across miles of seafloor, and communicate, somehow, without movement or voice. From above, they look like terrain, but they're alive. The term animal forest is not poetic license. It is used by deep-sea biologists who, upon witnessing these communities through the eyes of submersibles, recognize in them a strange and orderly complexity. Tall stalks rise from the sediment, sometimes meters high. Delicate glass sponges form branching towers of silica, as fine as lace, yet sturdy enough to endure millennia. Clusters of core-like animals, white, crimson, or translucent. The ridges and slopes, forming what appear to be flowering gardens beneath the ocean's most hostile realms. Tube worms, perhaps the most iconic members of these forests, can reach heights of 6 feet or more. They anchor themselves near hydrothermal vents, their bodies sheathed in long, parchment-like tubes. Lacking mouths or digestive tracts, they survive through symbiosis with bacteria housed within their tissues, microorganisms that convert the chemicals of the vents into energy. In return, the worms offer them shelter, warmth, and a stable place to work. These tube worms do not wander. They do not hunt. They grow. They rise. They form clusters so dense and organized they resemble thickets or groves. Glass sponges add another layer to these forests. Their skeletons, formed from silica extracted from seawater, are intricate frameworks of geometric precision. Some resemble vases, others towers, others vast, connected webs. They are filter feeders, drawing in water and extracting particles so minute that even silt passes through untouched. Entire fields of these sponges have been found on the ocean floor, some spanning miles, glowing faintly under the light's ROVs, their forms so symmetrical and fragile that they seem artificial. And yet they're alive, ancient, and active. The coordination within these animal forests is a mystery. While many of the organisms are sessile, fixed in place, their arrangement is not random. Certain species cluster together, others form perimeters. Some avoid each other entirely. These spatial patterns suggest interaction, either direct or chemical, at a level we do not yet understand. It may be that the currents themselves carry cues, chemical trails, temperature gradients, pheromones, that these animals detect and respond to over long periods of time. Or it may be that evolution has sculpted them to grow where they are needed, forming invisible networks of cooperation. Some coral communities grow in rings or spirals, forming shapes that repeat across miles of terrain. Others build up steep reefs, not a calcium carbonate like their shallow cousins, but of softer, protein-based materials. These reefs can harbor hundreds of other species. Brittle stars curl around sponges, crabs climbing across tube worm stalks, fish hiding in crevices between coral towers. Every surface becomes a niche. Every crevice, a possibility. In some regions, such as the cold seeps of the Gulf of Mexico or the methane-rich slopes off the Pacific Northwest, entire communities gather around chemical emissions. These seep forests are often invisible until illuminated by submersibles. Once seen, they reveal startling densities of life. Clams with no digestive organs, shrimp with light-sensitive backs, white mats of bacterial colonies covering the ground like frost. These are forests without photosynthesis, where light is absent but energy still flows, from chemicals, from vents, from the slow decay of the Earth's interior. Some animal forests are old, very old. Certain sponge reefs off the coast of British Columbia have been dated to more than 9,000 years in age. Their growth is glacial, measured not in seasons, but in centuries. Damage done to them, by trawling nets, by sediment plumes, may take generations to repair, if at all. And yet they persist, anchored in time, silent witnesses to the movements of the seafloor and the slow migrations of the species they shelter. ROV footage of these forests often evokes a quiet awe. The lights sweep across what looks like terrain, but then the camera zooms in and reveals breathing, swaying, pulsing life. The tube worms retract slightly. The sponge pores shimmer. Tiny shrimp dart between structures. It is not motionless. It is merely still. The way of forest seems still until you stop and listen. The scale of these communities is difficult to describe. Some cover entire underwater plateaus. Others form narrow ridges that snake through trenches. The largest known coral reef in the deep sea, discovered near New Zealand, stretches for hundreds of kilometers, and yet was only found recently, hidden by depth, by darkness, by the simple fact that we rarely look where it grows. Within these animal forests, time moves differently. Growth is slow, movement is rare, communication is quiet, perhaps chemical, perhaps mechanical, carried through vibrations in the substrate. There is no noise, no haste. Life unfolds gradually, patiently, in cycles measured in decades or more. What appears inert to the eye is, in truth, dynamic. Microscopic exchanges take place constantly. Larvae drift in and settle. Symbionts multiply. Predators graze carefully on what is offered. The animals of these forests are not just survivors. They are architects. Their presence changes a landscape. Tube worms oxygenate the sediment. Sponges filter vast volumes of water. Corals build habitats from their own skeletons. Over time, these effects accumulate, transforming barren ground into a living topography, rich, layered, and interdependent. Remove the animals, and the terrain collapses. The forest is not just a collection of life. It is a structure that supports it. And yet, we know so little. Many of the organisms that make up these forests remain undescribed. Their life cycles, genetics, and interactions are only now being studied. For every film sponge or worm, there are likely dozens more never seen. The deep sea keeps its secrets well, and it reveals them only to those patient enough to watch. The idea of terrain made of life forces us to reconsider our definitions. A forest can sway without wind. A reef can pulse without tide. Life, when given time and space, organizes itself into systems that echo the landscape's surface, but with rules all their own. In the dark, the animal forests stand, not quietly but steadily, breathing, filtering, growing, holding space for other creatures. They are ecosystems, yes, but they are also memories, records of stability in a world defined by change. Perhaps, even now, as you listen, there is a forest growing in the dark, its towers rising inch by inch, its filaments swaying, its colonies whispering in the current. It will not be seen for decades. It may never be seen, but it grows all the same. And in that growth, in that silence, something ancient continues, beyond name, beyond knowledge, beyond the edge of light. Not far from the thermal scars of undersea ridges and the quiet slopes of deep continental shelves, there lives a creature so fragile in form, yet so enigmatic in function that it continues to perplex those who study it. The glass sponge, more specifically, a family of ancient skeletal animals known as hexactinellids. At first glance, they appear passive, delicate cages of silica anchored in silence. But beneath their rigid exteriors lies a system that may represent something altogether more profound. Some scientists now believe these creatures do something no other sponge does: process information. The puzzle begins with their structure. Unlike other animals, glass sponges don't have a brain, nerves, or muscles. Their bodies are made of tiny interlocking spicules, microscopic glass needles that form intricate lattice frameworks. These structures are not simply beautiful, they are functional. They give the sponge shape and integrity, and also allow for a slow but constant filtering of seawater. Water enters through pores, flows through chambers, and exits through larger openings, carrying with it particles, nutrients, and gases. This is the basic sponge model. But hexactinellids do more. Unlike their shallow water relatives, which rely on slow-moving cilia or cells called choanocytes to pump water, glass sponges are syncytial. This means much of their internal tissue is not divided into individual cells, but instead forms one vast continuous cytoplasmic network, a single interconnected body. Signals can move freely across this structure without passing through membranes. There are no nerve cells, but there is communication. Researchers have observed something remarkable. When disturbed by a change in light, a shift in water chemistry, or a physical touch, hexactinellid sponges respond. Not passively, not mechanically, but in coordinated waves, as though the entire organism is aware. The sponge halts its filtering activity. The flow through its canals slows or stops. Minutes later, it resumes. The response is not random. It's regulated, repeatable, and surprisingly specific. This behavior was first recorded during laboratory studies where sensors monitored water flow through live glass sponges. When one part of the sponge was stimulated, the flow halted not just locally but throughout the organism, sometimes even reversing temporarily. This suggested that some signal, chemical, electrical, or mechanical, had been transmitted across the sponge's body. But how? The answer may lie in their syncytial structure. Because there are no cell walls to interrupt communication, ions and molecules can move freely, spreading information across the entire organism almost instantly. This kind of signaling is known in plants and some fungi, but in animals it is rare. And here, in the deep sea, a creature with no nerves may be responding to an environment with a coherence that mimics thought. Some researchers have even begun to describe this system as a kind of proto-intelligence. Not consciousness, certainly, but something more than reflex. A sponge that decides when to filter, that senses and processes disturbance, that integrates information across its body and coordinates its response. For a life form without a brain, that is extraordinary. And this is not speculation. Experiments have shown that the same sponge, when disturbed in the same way multiple times, will sometimes respond differently. A light touch might halt its pumping once, but not again. A chemical pulse might trigger a full-body reaction until it no longer does. These changes are not damage. They are variation. Choice. The sponge, it seems, learns in some primitive way, or at least it adapts. The implications are profound. Intelligence, or at least information processing, may not require a nervous system. It may arise in any sufficiently complex, interconnected structure, be it neural, cellular, or cytoplasmic. The hexactinellid sponge becomes a window into an older model of sensation, one not based on synapses, but on networks, on gradients, on flow. And consider this, many of these sponges are incredibly long-lived. Some specimens are believed to be over 10,000 years old. In that time, they have survived shifting currents, rising sediments, chemical changes, and occasional contact with other life. Through all of it, they have monitored their surroundings, modulated their activity, and maintained their delicate filtering architecture. That endurance, coupled with their strange, responsive biology, suggests a quiet sophistication. Some scientists have gone further, looking at the regularity of their skeletal patterns, at the almost mathematical precision of their growth, at their symmetrical canals and pores. They speculate whether the sponge's form itself might encode information, Could the lattice of silica be more than support? Could it act as a physical memory, recording changes, guiding future growth? We don't yet know. But the very question reveals how little we understand about these glass creatures. ROVs have captured entire fields of hexactinellid sponges, standing upright like frozen sculptures on the seafloor, their long cylindrical bodies swaying gently in the slow current. They appear inert, but they are filtering thousands of liters of water each day. They are adjusting, reacting, coordinating. From above, they resemble a quiet forest, brittle, pale, yet somehow alive in ways we're just beginning to sense. There is no drama in their existence, no violence, no hunt, and yet, within each sponge is a world of microscale motion. Particles pass through canals. Signals ripple across cytoplasm. Structures shift and realign over hours and days. They live in the silence, not despite it, but because of it. To consider that a creature without nerves might still feel its surroundings, respond to them, and modify its behaviors to expand our view of life itself. Intelligence is not binary. It does not flick on like a switch when brains evolve. It emerges gradually through sensitivity, pattern, and adaptation. The hexactinellid sponge may be among the earliest to show this quiet form of awareness, not in thought, but in action. So the next time a camera glides past one of these glassy towers in the deep, it may be passing not just a passive filter, but a listener, a processor, an organism that, in its own way, notices. There are no eyes, no ears, no language, but there is signal and response. And in the darkness of the deep, where pressure reigns and time moves slow, perhaps that is all that life needs. Not words, not thought, just the ability to know the water has changed, and to change with it. Far beneath the ocean surface, where darkness becomes a kind of atmosphere and pressure turns silence into weight. The deep does not lie still. It speaks, not in word or language, but in sounds, strange, fleeting, rhythmic, or hauntingly continuous. These sounds are not caused by whales, ships, or seismic events. They have no known animal to claim them, no matching movement on sonar, no source visible to any camera. And yet they echo across the abyss. The hydrophones hear them, record them, archive them, and still they remain unexplained. These are the abyssal whispers. Across the world's oceans, deep-sea listening stations, installed for everything from submarine detection to marine biology research, have recorded these sounds for decades. Often, they are dismissed at first. A glitch, perhaps, an interference. But they return, sometimes at the same hour each day, sometimes for months, sometimes only once, never again. Each sound has its own name, often based on the place it was recorded or the feeling it evokes. The bloop, the upsweep, the train, the Julia, the slow down. These names are innocent, but the sounds themselves are anything but. Take the bloop. First detected in 1997 by hydrophones positioned far across the southern Pacific Ocean. It was a low, powerful rumble that rose in frequency before fading into silence. What made it extraordinary was not just its tone, but its scale. The sound was so loud it was recorded by multiple listening stations more than 3,000 miles apart. For years, researchers speculated. Was it biological? Geological? The NOAA eventually suggested it was likely ice calving from Antarctic glaciers, but many remain unconvinced. No known ice shift matches its acoustic signature, and no corresponding surface disturbance was observed. Then there is the upsweep, a strange narrow-band sound with rising frequency that occurs in repeating bursts. It has been heard every year since 1991, mainly in the Pacific, and tends to peak in spring and autumn. The pattern is so regular, it resembles a language or at least a signal. But there is no sender, no device, no creature, just a sound, pulsing softly through the dark. The Julia was recorded in 1999, a long, descending moan, like something immense exhaling underwater. It lasted for about 15 seconds. No whales were present, no seismic activity nearby. It came and it went. Some listening stations marked it as unusually loud, but nothing appeared on satellite or sonar. Its location was roughly mapped to a deep trench. That's all. These sounds do not appear to travel with a visible source. Submersibles sent to investigate the regions where they originated find nothing. No unusual terrain, no damaged equipment, no living creatures large enough to account for them. Sometimes the water is calm. Sometimes there are strange currents. But always, the sounds arrive alone. They are not accompanied by light or vibration or heat. Only sound. One of the most disturbing is the slow down. Recorded in 1997, it began as a high-pitched tone that descended slowly over about 7 minutes. It was heard across nearly 2,000 kilometers of ocean. No known natural process creates such a slow frequency drop with that level of power. It resembles, in a strange way, something massive grinding to a halt, a machine powering down. But there are no machines there, only blackness and the deep. Then there's a train, so-called because it resembles the sound of distant rolling wheels on a track. It goes on for hours, a low, rhythmic thrum that pulses beneath the water like an engine with no origin. It has been heard in several parts of the ocean, always in the deep, always far from shipping lanes or seismic fault lines. Some researchers believe these sounds could be caused by unknown species, massive filter feeders or migratory leviathans whose sonic profiles don't match any known whale or fish. Others suggest they may be from geological sources still not understood. Subsea caverns collapsing, new hydrothermal vents opening, or even shifting plates grinding at the micro level. But none of these theories explain the scale, the regularity, or the acoustic patterns these sounds often exhibit. The deep ocean is an ideal medium for sound transmission. Water is dense, and pressure at depth prevents rapid dispersion. Sound can travel for thousands of kilometers without losing much strength. This makes it possible for something small to sound large, and something large to remain hidden yet loud. It also means our perception is limited. We can hear the sound, but not judge how far it truly traveled. A sound recorded in one trench could have originated in another hundreds of miles away. Hydrophones offer no image. They do not see, only listen. They capture pressure waves and convert them into audio, raw, filtered, often abstract. Some recordings are sped up so humans can hear them. Others are left untouched, a deep, slow voice from a place we cannot reach. Listening to these recordings is a strange experience. Some are beautiful, rising and falling like a song. Others are abrupt and violent. A sudden crack, followed by silence. Some sound like breathing, some like calling, some like screaming. Yet there is no fear in these sounds, only mystery. They represent a kind of communication we don't yet understand, not because we lack technology, but because we don't yet know who or what might be making them. Some sounds repeat for decades. Others arrive once and are never heard again. Their ephemerality makes them all the more strange. It is as if the ocean is whispering in a language we were not meant to decode. Researchers catalog these sounds, not just for curiosity, but in the hope that patterns will emerge. They mark location, time, depth, frequency, and amplitude. Files grow, archives deepen. Still, the ocean speaks in riddles. To imagine these sounds is to picture a darkness filled with presence, a vast volume of space where something moves, not visibly, but audibly. Something that perhaps doesn't need to be seen to be known. Perhaps it speaks through vibration. Perhaps it hunts with sound. Perhaps it merely exists, massive and indifferent, its passing marked only by the faint echo it leaves behind. The abyssal whispers remind us that the deep is not silent. It is alive with resonance. It hums, it pulses, it calls out, and we, listening at the edge, catch only fragments, echoes, moments, a single note in a vast composition whose source we have never seen, and perhaps never will. In the hushed expanse of the deep ocean, far below the surface where pressure rises and light dissolves, some animals defy our expectations not by what they are, but by how large they become. There in the cold and crushing dark, shrimp grow the size of small dogs. Jellyfish trail tendrils like cathedral tapestries. Isopods swell into armored giants. Squid reach lengths that rival city buses. This phenomenon is known as deep-sea gigantism, and it remains one of the ocean's most persistent and poetic mysteries. Why? In a place of such scarcity and constraint, do some creatures grow so enormous? Gigantism in the deep sea seems counterintuitive. Resources are limited. Temperatures hover near freezing. The environment is slow, quiet, and often barren. And yet, this is where some of the largest invertebrates on Earth are found. One of the most iconic examples is the giant isopod, a close relative of the pill bug. While its land and shallow water cousins measure only a few centimeters, the deep-dwelling Bathynomus giganteus can grow over half a meter long. Its hard shell and curved body look almost prehistoric, and it moves with a calm patience across the sediment, scavenging what little falls from above. Another marvel is a giant squid. Elusive and rarely seen alive, it is known mostly from carcasses and fragments recovered from the stomachs of whales. With eyes the size of dinner plates and arms covered in serrated suckers, it represents an apex predator of the deep. Some specimens are estimated to reach lengths of over 13 meters. And then there's a colossal squid, even larger and heavier, with swiveling hooks at the ends of its tentacles, adaptations that seem built for battles in the lightless void. Even creatures without a menacing profile grow large in the depths. Jellyfish like Stygia medusa gigantea drift silently with umbrella-like bells over a meter wide. Their long, ribbon-like arms, nearly invisible in the dark, may extend more than 10 meters. Deep-sea amphipods, tiny crustaceans in most environments, can grow to several inches long at depth. The pattern is clear. In the abyss, some animals become giants. But why? One theory is tied to temperature. Cold water slows metabolism and growth rates. Creatures that live in such conditions often grow more slowly, but they continue growing for longer periods. This extended development window, combined with delayed reproduction, may result in much larger adult sizes. The deep sea offers a stable, cold environment where such long-lived strategies can play out over decades. Another explanation involves oxygen. Cold water holds more dissolved oxygen than warm water. This surplus allows animals to sustain larger body sizes without exhausting their internal systems. In some species, oxygen availability is a limiting factor for growth, but in the depths, this constraint eases. Larger bodies become viable. There is also the matter of pressure. At extreme depths, pressure can influence cell structure, enzyme activity, and tissue density. Larger body sizes may provide more room for specialized structures that help organisms manage pressure-related stress. A bulkier organism may also be more structurally resilient, less prone to damage in a high-pressure environment. But perhaps the most compelling explanation is energy conservation. In the deep sea, food is scarce. Most sustenance comes from above, a slow rain of organic particles known as marine snow, or the occasional fall of a dead whale or fish. In such a lean ecosystem, being large can be advantageous. A bigger body means more storage capacity for food. It means longer survival between meals. It may also reduce the frequency of risky movement. Giant isopods, for example, can go for weeks or even months without feeding, relying on stored energy and low activity levels. Larger creatures may also be more effective predators or scavengers in the deep. Their size allows them to cover more ground, to detect chemical cues from further away, and to outcompete smaller rivals. For species like squid or jellyfish, long appendages increase the chance of detecting or ensnaring prey in the dark. Size becomes both a tool and a buffer against uncertainty. It's worth noting that deep-sea gigantism isn't universal. Many deep-sea organisms are small, delicate, and minimal. The phenomenon seems to affect certain taxonomic groups more than others, crustaceans, cephalopods, and cnidarians in particular. It may be an evolutionary response that depends not just on environment, but on lineage. And yet, even with all these theories, no single cause fully explains the pattern. The phenomenon is likely the result of multiple overlapping factors: temperature, oxygen, pressure, food availability, life history. It is not a rule, but a tendency, a suggestion written into bones and flesh of certain animals, shaped over millennia in the silence of the sea. Gigantism adds another layer of wonder to the deep. It challenges our assumptions about what the deep ocean should be, a place of limitation, of scarcity, of small lives. Instead, it offers bigness, a slow bigness, a quiet bigness. Not showy or aggressive, but enduring. These are creatures built not for conquest, but for survival. And in that endurance, there is something almost serene. The isopod trundles slowly across the sediment. The jelly pulses with ancient rhythm. The squid glides like a whisper. Their size is not just physical, it is temporal. They move slowly through long lives, adapted not for drama of the surface, but for the stillness below. To witness them, if only through grainy footage or a distant sonar, is to feel the scale of the planet in a new way. Not upward into space, but downward into depth. The giants of the abyss are not here to be found easily, but they are there, and they remind us that mystery lives not in absence, but in the sheer, quiet presence of life beyond measure. In the deepest corners of the sea, where even the boldest color fades to gray and light itself dissolves before reaching the bottom, evolution takes a different path. It does not shout. It does not decorate. It vanishes. Here, in the cold quiet of the abyss, some creatures abandon pigment altogether. Others seem to relinquish form itself. Their bodies become see-through, pale as mist, or so hollow they barely register as matter. These are the transparent and hollow, organisms shaped more by absence than by presence. Invisibility becomes survival. Emptiness, a kind of power. Consider the glass squid, a creature whose name captures its essence. Found drifting in mid-water depths, it floats like a thought, its body nearly invisible. Most of its tissue is translucent. Light passes through with little distortion. Only its eyes and digestive organs remain slightly visible, floating like shadows within a ghost. The effect is haunting. A creature present and yet not fully there, a ripple in water rather than a solid form. Then there are the clear eels, juvenile forms known as leptocephali. When first discovered, they were thought to be entirely different species. Their ribbon-thin bodies, gelatinous and glowing faintly, seemed too alien to match adult eels. It wasn't until much later that researchers realized these were larval stages, designed to survive long journeys in the open ocean with minimal visibility. They are almost entirely made of water, with thin layers of tissue stretched like silk across invisible frames. No color, no bones, no defense, just transparency. This trend appears across multiple phyla. Deep-sea shrimp, jellies, comb jellies, and even some fish all abandon opacity. Their organs flatten. Their pigments fade. Even mussels may lose their density, replaced with soft, gelatinous tissue that neither reflects nor absorbs light. These animals are not weak. They are adapted. In the deep, where visibility is rare and predators use bioluminescence to spot silhouettes, the safest form is no form at all. But transparency is not just camouflage. In some cases, it serves as insulation. Gelatinous bodies contain water, yes, but also structure. Their softness is a buffer against pressure, allowing them to float in place without expending energy. Hollow organisms can drift passively, adjusting their buoyancy by slight changes in internal chemistry. No need for dense organs, bones, or thick tissue. In a world defined by scarcity, the best design may be minimal. Take the barrel-eye fish. Its head is a dome of transparent tissue, and its tubular eyes point straight upward to the clear casing. For decades, its anatomy confused researchers. The visible eyes on the front of its face are actually nostrils. The real eyes, embedded in the clear shield of its skull, rotate to track movement above. This adaptation allows it to scan the silhouette of prey while remaining nearly invisible from below. It's not just a trick of biology, it's strategy written in flesh. The pelagic sea cucumber, Enypnias, floats through the water like a drifting balloon. Its body is clear and gelatinous, revealing its simple internal systems. When it encounters sediment, it drifts downward, collects a thin layer of nutrients, and floats upward again. It lives in slow, ghost-like loops, appearing and vanishing like a deep-sea wraith. Even octopuses have taken this path. The glass octopus, Vigilanella richardi, is nearly invisible save for its optic nerves, digestive tract, and a tiny ring of pigment around its eyes. It hovers in the mid-water realm, where light from above is faint but still enough to silhouette a solid form. By becoming transparent, it avoids detection from both predators above and prey below. Its invisibility is not an illusion. It is real. And in some creatures, transparency gives way to something stranger, hollowness. Some deep-sea animals seem to lack not just color, but content. Their bodies are so lightly constructed that they appear to be filled with nothing. Their tissues are stretched thin, their cores made of fluid or gas. They move slowly, with little resistance. They pulse or drift, not by propulsion, but by simple undulation. These creatures are made not for action, but for presence. They are quiet witnesses of the deep. The deep-sea jellyfish Pithecanthropus bouilloni resembles a floating ghost lantern, with a barely visible bell and faint blue light within. It has 8 arms, barely discernible, and drifts in silence. Its form is less animal than atmosphere, a blur of life against a canvas of black. In many of these species, organs are not just hard to find, they may be reduced to near non-existence. Digestive systems shrink. Reproductive organs develop only during mating seasons. Muscles become ribbons. Even the nervous system may be decentralized, spread thin across the body like a net. The body becomes a platform, not a machine. This raises questions not just about visibility, but about what it means to be an animal. These beings defy the boundaries of anatomy. They are not defined by skeleton, color, or solidity. They are, instead, defined by function. They survive. They drift. They feed. They reproduce. And then they disappear, vanishing not just into the dark, but into the very water they inhabit. Transparency is not just a strategy. It is a philosophy of form. These animals do not fight to be seen. They dissolve into their environment, becoming part of it. They are made of light and water, of silence and motion, of thresholds. You see them only when light hits just right, or when a shape shifts slightly. Then, just as quickly, they are gone. To study them is to study presence by absence, to measure the body by its refusal to block light, to listen for life that does not announce itself. It is a practice of attention and reverence. Perhaps that is why they linger in the imagination, not as monsters or marvels, but as reminders that life takes many forms, some bright, some armored, and some so soft, so invisible, that they're felt only in their passing. In the deep, the clearest things are often the hardest to find, and yet they are there, watching, moving, hollow and whole, somewhere beneath the silent churn of the sea. In trenches deeper than the tallest mountain is high, entire machines lie entombed in pressure and darkness. Submarines, once symbols of precision, control, and technological mastery, now sit lost at 20,000 feet or more, their hulls crushed or quietly intact, their final moments undocumented. But what makes these disappearances so haunting is not only their mystery or the tragedy of lost crews, it is a suggestion that, in their final descent, some may have crossed into ecosystems unknown to science. That perhaps, before vanishing, they glimpsed something no human was meant to see. The deep sea is vast and largely unmapped. The abyssal and hadal zones stretch across entire continents, forming ridges, canyons, and crevasses that remain outside the reach of even modern sonar. It is here, in these spaces, that more than a dozen submarines, military, research, or experimental, have been lost. Some in wartime, others in peace. Some with clear mechanical failure, others without a trace. One of the most famous cases is the USS Thresher, lost in 1963 during deep diving trials east of Cape Cod. It was the most advanced attack submarine of its time, its systems tested and refined. And yet, during a routine dive, it went silent. A garbled message was received, then nothing. The vessel imploded at depths estimated near 2,400 meters. Recovery missions found only scattered debris. Official reports cited mechanical failure, but classified sonar recordings revealed strange, rhythmic pulses just before final contact. Some described them as mechanical echoes. Others weren't so sure. Another case, the Soviet K-129, which disappeared in 1968 in the North Pacific. Its wreck was later partially recovered in secret by the CIA using a specially constructed vessel, the Hughes Glomar Explorer. But only part of the submarine was retrieved, and what lay in the missing section remains unknown. Naval personnel close to the mission reported structural damage inconsistent with an explosion or impact. The hull appeared to have folded inward, as if compressed by forces not yet understood. One anonymous source, in a declassified interview, mentioned scarring along the outer shell, long, linear grooves that suggested pressure or something else. In recent years, attention has turned to small private submersibles used for research and tourism. These crafts, while advanced, lack the resilience of military submarines. Several have gone missing temporarily, and one, an unreported sub used for extreme depth exploration in the Western Pacific, is rumored to have vanished after descending into a trench beyond surveyed depth. No distress signal, no beacons, no debris. While official explanations often cite equipment failure, there are whispers of stranger things. In one recovered data log, sent before contact was lost, a pilot described movement outside the glass at depths beyond 6,000 meters. Bioluminescent shapes, too large, too slow to be fish. One even reported a rhythmic pulsing sound, unlike known deep-sea rumbles. Another log, pulled from a black box retrieved years after sub's implosion, included a note. The lights moved in patterns. What could be down there? The ecosystems of the Hadal Zone are only now being studied in detail. These regions, deep trenches like the Mariana, the Kuril-Kamchatka, and the Sunda, harbor extremophiles, ghostly amphipods, and microbial mats that thrive on methane and sulfur. But this is only the beginning. Some sonar pings in these areas return strange signatures, broad masses that move slowly or vanish mid-scan. Submarines venturing into these zones have reported odd temperature fluctuations and acoustic anomalies that don't align with known currents or tectonic movement. It's not just the unknown species, either. It's the absence of signal. Some deep-sea explorers describe long minutes when sonar goes blank, when instruments reset, when light refuses to reflect, as if something enormous, invisible, or simply not recognized by our technology, moved through. There are stories, quiet ones, of researchers feeling watched while in submersibles, of lights appearing in the distance, moving deliberately, of entire areas growing inexplicably dark, as if a shadow had passed overhead, though no surface object was above. These accounts are rare, often dismissed, and nearly always anonymized. No pilot wants to risk their credibility, but they add weight to a question. When submarines vanish, are they merely breaking, or are they being watched? There is no evidence, only fragments, debris fields, incomplete sonar, empty logs. But time and again, the disappearances happen in places where life remains unknown. The oceanic trenches are not barren. They are not still. They are living. When a submarine descends into the deep, it brings with it more than steel and technology. It brings heat, vibration, electromagnetic signals. To us, these are normal. But to whatever lives at depth, adapted to silence, darkness, and the slow rhythm of chemical pulses, such signals may stand out like a flare in the night. The arrival of a vessel may be more than an intrusion. It may be a call. Some scientists have speculated that deep-sea gigantism and bioluminescence could serve communicative functions among abyssal species. If so, our machines may have been speaking a language without knowing it, and in reply, perhaps something came close, not to attack, but to understand. In the aftermath of sub-disappearances, recovery teams often find curious details, hulls deformed in unexpected ways, unexplained time gaps in black box logs, acoustic recordings filled with low-frequency patterns that resemble songs or warnings. What if these incidents are not accidents? What if, at certain depths in certain regions, life emerges from the dark not just observe, but to interact? We build submarines for exploration, but the ocean has its own boundaries, and we may not know when we've crossed them. Even the language we use, lost, crushed, vanished, implies ignorance. We don't say found. We don't say seen, because we haven't. The Hadal realm remains largely untouched. It does not yield its secrets easily. Still, the questions linger. A sonar ping, received long after the final contact, echoing up from an abandoned trench. A piece of hull found covered in microbial growths not cataloged anywhere. A video file corrupted beyond repair, except for a few seconds of pulsing, rhythmic light. There is no proof, only a whisper from the deep, and a list of names, etched into memory. Crews who disappeared not into fire or storm, but into the calm, quiet black, into places where the map ends, into ecosystems we cannot name, into a presence that watches, but does not speak, in the blackness of the deep sea, where light fades entirely and colors disappear one by one. A strange rule of nature emerges. If a creature glows, it glows blue. This is not just a pattern. It's a design. Blue light travels furthest through water, cuts through the dark most efficiently, and is the wavelength most other deep-sea animals can see. Evolution has leaned into this. Blue is the language of the abyss. And yet, scattered like whispers through the trenches amid waters, are exceptions. Beings that glow not blue, but red. It is not a soft red, not the warm glow of a fire or the deep blush of dusk. This red is alien, cold, faint, rare, but unmistakable. And in the deep, it means something else entirely. Secrecy. Most deep-sea animals are blind to red light. Their eyes are built to detect blue and green, the wavelengths that remain at depth. Red, with its long wavelength, is filtered out by water within just a few meters of surface. As a result, almost nothing below a few hundred meters reflects it, sees it, or responds to it. So why would a creature produce it? The answer lies in a kind of invisible spotlight. A few predators, like the dragonfish and the loose jaw, have evolved the ability to emit red bioluminescence, and to see it. Their light beams are invisible to their prey. It's a biological form of night vision. They hunt by a glow no one else can perceive. The loose jaw, or Malacosteus, is perhaps the most haunting of these predators. Its lower jaw is hinged like a trap, its body long and narrow, built for stealth. Along its face are light-producing organs, photophores, that emit both blue and red light. But only the red is used for hunting. The loose jaw's eyes contain pigments rare in the deep sea, allowing it to detect its own red glow. When it swims, it casts a narrow red spotlight forward, illuminating prey that swims unaware, believing itself cloaked by darkness. It is an evolutionary cheat code. Most other deep-sea creatures have evolved camouflage that fools blue-sensitive vision, but they remain perfectly visible in red. The dragonfish, too, uses this strategy. Its long body is covered in iridescent scales, but its secret weapon is a suborbital photophore, a red light just beneath the eye. This red beam lets it scan its surroundings in complete secrecy. What makes this adaptation so fascinating is how rare and specific it is. Producing red light requires different biochemistry. The luciferin-luciferase systems used in most blue bioluminescence are not the same. Red light production is harder, less efficient, and only useful if the creature can also see it. So why go to all that evolutionary trouble? Because in the deep, vision is power. In a world of shadows and silhouettes, being able to see when others cannot is the ultimate advantage. The red glowing hunters of the deep are not just predators, they are spies. Some researchers believe there may be more red glowing creatures than we currently know, but their light is invisible to standard deep-sea cameras. Most submersible equipment is tuned to capture blue and green wavelengths, missing the red entirely. In fact, some of the first red glowing specimens were only detected because of the strange behavior of nearby animals. Prey fish that suddenly scattered or swam erratically, seemingly reacting to something unseen. Later, when those regions were examined with red-sensitive equipment, faint pulses were detected, narrow, directed, like beams from a flashlight. There are even rarer cases of creatures that glow entirely red, rather than casting beams. Some jellyfish, when disturbed, pulse with a soft red shimmer. Others, like certain comb jellies, scatter red sparks across their gelatinous bodies. These displays are brief but unmistakable. Whether they serve to confuse predators, attract mates, or signal distress, we don't yet know. The glow itself is beautiful, darker than crimson, deeper than rust. It seems to move slower than blue. It feels old, as if it were the memory of light rather than light itself. There's also something unsettling about it. Red, in the deep, breaks the rules. It suggests awareness, strategy, the ability to manipulate a system most creatures are still blind to. And for the creatures that produce it, red may not be a warning or an accident. It may be a whisper meant only for a chosen few. Some deep-sea shrimp have been found with reflective surfaces that bounce red light instead of absorbing it. Others carry red pigmentation, even in total darkness, as if shielding themselves from detection by red-sensitive hunters. It is a quiet arms race, glow and counterglow, vision and concealment, all playing out at depths no sunlight has ever touched. Even stranger are reports from submersible pilots and ROV operators who have seen unexplained red pulses at depth, not from known species, not in any specific pattern, just a faint shimmer in the distance, a soft pulse, then silence. Attempts to follow the source often lead nowhere. Could there be creatures whose entire communication system is red light based, speaking in invisible flashes, too brief or too faint for us to catch? Could they be watching us, unseen, even as we scan with sonar and beam our white lights into the dark? It's possible. In fact, probable. Our instruments are limited. Our understanding, even more so. Red light might not just be a hunting tool, it might be language. The ocean has never given up its secrets easily. But the creatures that glow red remind us that evolution does not settle. Even in places where no eye should see, life finds a way to look. And even in the blackest silence, there are whispers in crimson. In the deep, color is more than decoration. It is survival. And those who carry the glow of red do so with a purpose. Whether predator or signaler, guardian or ghost, they break the spectrum on purpose. And when they do, they light up the dark in ways we are only just beginning to understand. In the deepest reaches of the sea, where food is scarce and survival depends not on speed or teeth, but on innovation, life has found strange ways to feed. Down here, in the slow rhythm of cold and pressure, some creatures have given up mouths entirely. They do not bite or chew. They do not hunt. Instead, they absorb. They host. They become something like living chemistry, organisms that survive by blending with the environment or inviting it inside. This is feeding without a mouth. At hydrothermal vents and methane seeps, the rules of surface biology no longer apply. Sunlight doesn't reach these places. Photosynthesis, the process that powers most of life above, is meaningless here. And so, deep-sea life turns to chemistry. In these strange oases, some of the most alien creatures thrive by hosting bacteria that can convert chemicals like hydrogen sulfide or methane into energy. These bacteria, known as chemosynthetic symbionts, are the true eaters. The animals are simply the homes. The giant tube worm, Riftia pachyptila, is a prime example. It can grow up to 2 meters tall and looks like a blood-red feather poking out of a white tube. It has no mouth, no stomach, no intestines. Instead, it houses billions of bacteria inside a specialized organ called a trophosome. The worm absorbs hydrogen sulfide from the vent-rich water through its skin. The bacteria inside it then convert that chemical into organic compounds, feeding both themselves and their host. The worm is a body built around another organism's metabolism. Other vent-dwelling species follow a similar model. The clam Calyptogena magnifica has gills that serve a dual purpose, respiration, and hosting sulfur-oxidizing bacteria. These clams filter in hydrogen sulfide, and their internal guests do the rest. Over time, their digestive systems have shrunk, no longer needed. There are less animals that eat and more vessels that contain. Elsewhere in the deep, some sea cucumbers and polychaete worms feed by absorbing nutrients directly through their skin. The ocean floor is rich in marine snow, a steady drizzle of organic matter, microscopic debris, and the remains of plankton and animals from above. Creatures here lie still, letting particles settle on their surfaces, or draw in thin films of water, and extract nutrients molecule by molecule. They become living filters, feeding not through mouth parts, but through membranes. There are deep-sea sponges, too, that host complex microbial ecosystems inside their porous bodies. These microbes perform digestion at a cellular level, breaking down particles that the sponge never technically consumes. The sponge does not reach for food. It simply holds still and lets the water do the work. Even stranger are certain transparent, hollow creatures, salps, for instance, that pump water through their gelatinous bodies, absorbing dissolved organic compounds through a mucus net. They feed on the smallest particles imaginable, turning each pulse of water into a chance to extract a fraction of energy. In the icy darkness near Antarctic deep shells, there are starfish that glide slowly over the seafloor, pressing their undersides into sediment rich in bacterial films. They do not devour prey. They absorb. Like quiet vacuums, their tube feet and soft tissues draw on molecules over hours and days. In this world, speed is not the goal, endurance is. These strategies speak to a different rhythm of life. One that doesn't fight for food but accepts it, gathers it, hosts it. In this way, the line between organism and environment begins to blur. The bacteria are not parasites. They are symbionts. The water is not just habitat. It is nourishment. What these creatures lose in mobility or aggression, they gain in resilience. A fish with teeth must eat every day. A predator must chase. But a tube worm or symbiotic clam can go for weeks, even months, sustaining itself on chemical reactions invisible to the naked eye. These are not weak organisms. They are quiet survivors. And while this may seem alien, it isn't rare. In fact, many researchers now believe that this kind of metabolic partnership may be one of the earliest and most successful strategies on Earth. Life near vents, powered by chemosynthesis, likely predates life powered by sunlight, which means the creatures that feed without mouths are not anomalies. They are ancient. They also hint at how life might exist elsewhere, on icy moons like Europa or Enceladus, where sunlight never reaches beneath frozen oceans. Scientists theorize that life, if it exists, would rely on similar processes, not hunting, not feeding through mouths, but absorbing, hosting, living through others. Back on Earth, the more we descend, the more we find creatures that blur the lines between self and other, between feeder and fed. At certain depths, it becomes difficult to say where one organism ends and the next begins. To feed without a mouth is not just a change in mechanics of survival. It is to participate in something slower, more interconnected. It is a kind of patience, a letting go of urgency, a quiet trust in the environment to give, and in the self to receive without taking. And perhaps this is the most mysterious thing of all, that in the most extreme, most barren parts of the planet, life does not just endure. It collaborates. It listens. It becomes a space around it. And in doing so, it survives in silence, without hunger, without bite, without mouth. In the vast and pressure-heavy dark of the deep sea, where most life clings to invisibility, hunting takes on forms unlike anything seen at the surface. The predators here are not swift like sharks or strong like lions. They are shadows, tricks of movement, soft mechanisms that blur the line between tool and flesh. Some drift like ghosts until they strike. Others wait still for hours, then lunge in impossible ways. And some, we don't even know what to call them. These are the undocumented hunters. Creatures caught on camera only a handful of times, seen feeding in ways we cannot yet classify, belonging to no known branch of taxonomy. They exist on hard drives and in whispered reports, flickering briefly in footage recorded by deep-sea ROVs before fading back into the abyss. In one clip from a research expedition near the Kamchatka Trench, a transparent, balloon-like creature drifts into frame. At first, it appears passive, like a jellyfish or siphonophore. But then it expands rapidly, inflating its body into a globe nearly a meter wide. A passing fish swims too close, and in a motion so fast it's barely visible. The balloon contracts, drawing the prey inside without any appendages or suction cups. It's not a trap. It's an entire body acting as a singular reactive organ. No known species behaves this way. The video was marked unclassified gelatinous predation event. Nothing more. Another piece of footage, captured over the Puerto Rico Trench, shows a long, narrow organism resting in the sediment. Its body appears boneless, like a ribbon or loose worm. As the ROV approaches, a small crustacean comes into frame. Suddenly, without any coiling or wind-up, the organism launches its mouth outward, on a tether or muscular stalk, snatching the crustacean with precision. The mouth then retracts in the body, like a spring recoiling. The entire event lasts less than half a second. No eyes are visible. No defined segments. The creature vanishes into the sediment as quickly as it struck. These spring-loaded mouths are not entirely unheard of. Some deep-sea fish, like the dragonfish, have expandable jaws. But this was not a fish. No fin, no bone, no pigment. It looked more like fabric than flesh. And yet it hunted. Another ROV dive along the mid-Atlantic ridge recorded a different kind of hunter, a slow, hovering organism shaped like a half-deflated umbrella. Its underside was lined with fine hair-like structures. As it drifted to the water column, tiny organisms, copepods, larvae, plankton, were swept upward in currents and pulled into the fringe of this umbrella. The hairs vibrated, then contracted. The prey vanished. The umbrella pulsed softly and continued on. It moved like a jellyfish, but didn't match any known jelly anatomy. It lacked radial symmetry. Its tentacles were more like sieves. It hunted not by grabbing, but by filtering, with deliberate, selective precision. These undocumented predators challenge more than our taxonomic systems. They challenge our expectations of how life hunts. On land and in shallow waters, hunting is energetic, muscular. It requires eyes, limbs, tools. But in the deep, where energy must be conserved, predation becomes architecture. Some creatures reshape themselves entirely for the hunt. Consider the vacuum suckers. Creatures with wide, soft mouths that open so suddenly they create inward currents, pulling prey from several centimeters away. This form of suction feeding has been seen in some known fish, but never in the fully gelatinous creatures caught on film by deep ocean cameras. These hunters appear boneless, translucent, lacking visible musculature, and yet they feed rapidly, with suction forces that rival industrial pumps, all generated by collapsing a hollow body cavity in an instant. Because they appear so infrequently and are rarely observed in more than one frame or sequence, scientists are left with guesswork. Anatomy can't be dissected. Behavior can't be tested. Classification is impossible. These hunters remain without names, labeled in archives as unclassified predatory event, gelatinous ambush form, or simply unknown. And still, they appear, here and there. In a clip from a Mariana Trench descent, a bulbous organism flickers into frame and wraps its entire body around a smaller animal. No limbs, no mouth visible, just an enveloping, slow embrace. When it unfurls, the prey is gone. The predator floats away, half transparent, the outline of digestion barely visible within. Some researchers believe these animals may be evolutionary one-offs. Species so specialized, so fragile, that they never became widespread. Others think they may represent entire taxonomic groups that have never been collected, never netted, never even imagined. Still others suggest these predators are developmental phases of known animals, larval or intermediate forms that only hunt this way for a brief window before transforming. But even this theory has gaps. Many of the hunters recorded appear fully developed, functional, efficient. They show no signs of being temporary. The footage of these undocumented hunters is mesmerizing, grainy, silent, often lit only by the cold white of an ROV's beam. Their movements don't fit the grammar of biology textbooks. They don't lunge or stalk. They expand, collapse, ripple, swell. They wait, and then, in a blink, they feed. Watching them is like watching something from another planet. A world where flesh is liquid, and hunting is more like choreography than violence. Where the body is not just a vehicle, but a mechanism designed to alter shape, pressure, and presence in response to passing life. Perhaps what unsettles us most is the idea that such predators exist unseen. That for every frame of footage showing one of these hunters, hundreds pass without a camera. That down in the trenches and ridges, a different model of survival reigns. One that does not conform. One that we cannot yet name. And yet they are there, hunting slowly, or suddenly, waiting, or drifting. The deep sea does not celebrate speed or aggression. It rewards innovation, efficiency, stillness. These undocumented hunters are quiet revolutions in form. They break the mold. And in doing so, they remind us that the architecture of predation can be soft, gentle, ghost-like, and utterly unknown. In the darkest parts of the ocean, where sunlight is not just faint but extinct, vision becomes both impossible and essential. To understand the life that exists there, we must first learn how to see without light. And that means building cameras that do more than capture images. They must listen, wait, scan, and adapt. They must become extensions of human curiosity in a place where human senses fail entirely. These are the cameras in the dark. The first attempts to observe the deep sea were crude. Weighted cages, static frames, or steel spheres with small portholes were lowered into the depths, carrying film reels or primitive sensors. These early devices provided only hints, shadowy images, heat maps, murky outlines. They revealed that something was there, but not what. For a long time, the deep sea remained a place of speculation. But then came the remotely operated vehicle, or ROV. ROVs are machines built to descend beyond the limits of human endurance. Some dive past 11,000 meters, their hulls designed to withstand pressure equivalent to being under a mountain of rock. They carry cameras that don't just see, they interpret. In darkness deeper than any cave, the camera must act like an eye without a pupil, capturing the faintest glimmers of bioluminescence, heat, motion, or vibration. These cameras are paired with robotic arms, chemical sensors, sonar, and data links that stream information live to ships far above. Yet even these devices struggle. Water distorts. Cold slows. Particles in the water scatter light and confuse sensors. The ocean is not just dark, it is moving darkness. So the tools we build must adapt constantly. To illuminate a scene, ROVs use high-intensity lights. But this brings problems. Some animals are disturbed by artificial light, vanishing the moment a beam hits them. Others are drawn to it, changing their behavior entirely. Most deep-sea life evolved in perpetual night. Our lights may seem like explosions. To address this, newer ROVs now use red or infrared light, wavelengths many animals cannot detect. But red light does not travel far in water, so the camera must be close. Very close. In recent years, researchers have turned to ultra-sensitive cameras capable of filming in near-total darkness using the animal's own light, bioluminescence. These passive cameras don't illuminate the scene. They wait. They observe. They capture the glow of jellyfish, the flicker of photophores, the silent flash of a fish signaling to its mate. These images are grainy, ghost-like, but they are real. What surprises scientists most is not just what they see, but what they don't understand. Many ROV dives return with hours of footage containing organisms no one has classified, shapes with no symmetry, movements with no known purpose, light patterns that repeat without cause. Some creatures appear for seconds and vanish, never seen again. Others hover just beyond the field of view, outlines in the murk. Sonar adds another layer. Unlike light, sound travels far in water. ROVs and deep-sea observatories often use multi-beam sonar to map terrain and detect movement. But sonar too brings mystery. Shapes appear and disappear. Signals echo in strange ways. Some sonar traces resemble enormous moving organisms, hundreds of meters long, yet vanish when the camera approaches. Are these real optical illusions, temperature anomalies, or something we lack the tools to perceive? Then there are the anomalies, events caught on film that defy explanation. A set of videos recorded off the Galapagos Rift shows dozens of small, circular lights rising from the seafloor in coordinated waves. No known organism behaves this way. Another camera, lower near the Mariana Trench, captured a dark form that passed in front of the lens and blocked the entire field of view. No features were visible, just absence. Then it was gone. ROVs also record sound. Some deep-sea cameras are paired with hydrophones, underwater microphones that pick up low-frequency noises. These recordings are full of groans, rumbles, whistles, and clicks. Some can be identified. Whale calls, tectonic movement, ship engines. But many cannot. Rhythmic pulses, repeating tones. One sound, recorded multiple times near the chromatic trench, has no clear source and plays at regular intervals. 3 tones followed by silence. No animal is known to produce it. No machine matches it. It simply is. These unexplained recordings are filed away, stored in massive digital archives maintained by oceanographic institutes around the world. The footage, too, is cataloged. Some gets shared. Much of it doesn't. There are terabytes of video from deep-sea dives that no human has yet watched. Too much data, not enough time. Within those files may be creatures no one has ever seen, behaviors no one has studied, glimpses of biology as alien to us as life on another planet. That is both the challenge and the beauty of filming the deep sea. It is not about capturing spectacles. It is about recording patience. The best footage often comes after hours of stillness. Cameras drift, lights dim, silence grows, and then, slowly, softly, something moves. In one such sequence, a camera rests on the ocean floor near a cold seep. Nothing happens for almost an hour. Then a translucent creature, long with ribbon-like arms, drifts into frame. It hovers above a patch of microbial mat, pulses once, and emits a faint glow. Smaller organisms scatter. The creature floats upward and disappears. The camera recorded this once. Never again. Many of the devices that record these events operate autonomously. Landers and drop cams are lowered from ships and left for days or weeks. They film on motion triggers, light cues, or scheduled intervals. When retrieved, their footage is a silent library of moments, some remarkable, others mundane. But even the mundane matters. Each frame adds to our map of the unknown. Some researchers have proposed placing permanent cameras in the deep sea, networks of observatories that could film continuously for years. But the challenges are immense. Pressure, corrosion, power supply, data transfer. Still, progress is being made. The Ocean Observatories Initiative and similar projects are slowly building the infrastructure to watch the deep sea not as visitors, but as residents. Until then, we rely on brief glimpses. A camera lowered here, a dive filmed there. And in those moments, we learn that the ocean is not just deep. It is layered with the unseen. The camera is our eye, but even the best lens can only show so much. There are shapes that pass without detail, sound that ring without origin, lights that flicker in the periphery. The tools we build are extraordinary, but the deep is patient and full of things that do not want to be seen. Still, we watch and record and wait, because sometimes in the middle of the silence, the dark opens and something unknown swims through. In the deep sea, where light is a stranger and movement is slow, the ocean plays tricks not just on cameras, but on perception itself. The water bends light in ways that mimic life. It refracts motion into shape and shape into presence. Here, not everything that looks alive is. Not everything solid is real. And not everything seen is believed. These are the shimmering walls, optical illusions at the edge of reason. It begins with light, or the absence of it. In the upper ocean, sunlight filters down in bands and gradients. But beyond 200 meters, it vanishes almost completely. What remains is not true light, but bioluminescence, short bursts, flashes, glows, mostly blue, scatter like stars in black water. ROVs and submersibles introduce artificial beams to sea. But these beams do not travel far. They hit particles. They warp around heat. They ripple against the water itself. When light moves through the ocean, it bends. It refracts across thermoclines, layers where temperature shifts rapidly with depth. These boundaries are invisible but powerful. To the human eye, or to a camera, objects beyond a thermocline appear blurred, stretched, or displaced. A creature that's actually 10 feet away might seem to hover just inches from the lens. Its outline shivers, its edges duplicate. Sometimes, the same organism appears to flicker in 2 or 3 places at once. This is not imagination. It is physics. But to those watching from a submersible window or from a control room miles away, it feels like something else, like the sea is alive in ways that defy logic. One commonly recorded illusion is a shimmering wall, a curtain of vertical light that appears to hang in open water. It shifts gently like silk, but when approached, it disappears. This is often caused by gradients in temperature or salinity, combined with moving particles in the water. Light bounces unpredictably across these surfaces, creating the impression of something solid and near. Some researchers have even mistaken these for massive gelatinous organisms or vertical colonies, until they vanish on closer inspection. Mirages occur in water just as they do on land. Heat layers near hydrothermal vents or cold seeps can cause background light to warp into floating shapes. A shadow from a distant rock can stretch upward like a phantom. A drifting cloud of plankton can refract light in a way that mimics pulsation, making it seem alive, aware. In one recorded dive, a shimmering ring hovered in open water for nearly 20 minutes, reacting to light, changing shape. It was later determined to be a lensing effect caused by overlapping thermal layers. But in the moment, the ROV operators were silent. They didn't know what they were seeing. Sometimes, these illusions take the form of movement. Light from an ROV can scatter in one direction, while the particles it illuminates move in another. This creates a perception of swirling shapes, coils of brightness that seem to move independently. Some call them false eels. Others describe them as ropes of light. The effect is hypnotic and for a few moments convincing. Even sonar can fall prey to illusions. Sound reflects strangely in deep, layered water. An object that appears to be moving may be stationary. A stationary object may appear to pulsate. There are sonar returns of massive shapes slowly rotating, hundreds of feet across, that vanish when visual contact is attempted. In some cases, the echo itself seems to loop, repeating on a delay, like a memory trying to reassert itself. Glass sponges, tall tube worms, and other stationary creatures can become part of these illusions. When light hits their translucent bodies, it scatters internally. They glow not from within, but from the way light becomes trapped and redirected. From certain angles, these creatures appear to shimmer or breathe. From others, they vanish entirely. Entire forests of sponges have been filmed that seem to flicker in and out of existence, depending on the ROV's angle. Some illusions are interactive. Divers in mid-depth zones report seeing walls or blurs that move away as they approach. These are not organisms, but light boundaries, formed by cold fingers of water sliding past warm ones. The layers bend vision just enough to suggest something just out of reach. Cameras see them, too. Footage from these moments often shows a kind of wavering shadow. No detail, no texture, just a sense of presence. Even the bubbles from an ROV's descent or a diver's exhale can create reflections that mimic life. Air rises in columns, each bubble a tiny mirror. Together, they catch the vehicle's own lights and scatter them back in distorted patterns. The result is a shimmering pillar, alive with motion, but made of nothing. And then there are the ghosts of the sea. Not real spirits, but artifacts of technology. Sometimes, when video footage is slowed or compressed, movement is smeared. Low-resolution images stretch a glowing jelly into a multi-limbed entity. A flicker becomes a flap. These moments, though unintentional, create creatures that feel more imagined than filmed. They are mistakes, but poetic ones. The ocean's distortions don't just confuse, they enchant. In trying to film what we cannot see, we discover how limited our perception truly is. The tools we build to reveal truth also reveal our assumptions. We expect edges. We expect shapes. But the deep sea does not care for such things. It is a place of gradients, of soft divisions, of maybe. Researchers often say that understanding the ocean begins with understanding how little we can trust our eyes. It is a world of mirrors and lenses, of bending and blending. The deeper we go, the more unstable the act of seeing becomes. And yet we continue. We film the shimmer. We log the mirage. We study the shadows that move in rhythm with our lights. Because in the illusions, there is still information, even if we cannot touch it. The shimmering walls of the ocean are not creatures, but they are not nothing. They are the meeting points of matter and movement, of heat and cold, of light and dark. They are the ways the ocean tells us we are being watched, by itself, perhaps. And as we stare into the water, try and make sense of what moves, it becomes clear. The ocean does not always show us what is there. Sometimes, it shows us what we expect to see. Sometimes, it shows us only ourselves. At nearly 11,000 meters deep, the Mariana Trench is Earth's final descent. Its most profound silence, its most crushing pressure, and its most enduring mystery. This crescent-shaped scar in the seafloor stretches over 1,500 miles long, but its most iconic point is a Challenger Deep, a place so remote, so hostile, that fewer people have visited it than have walked on the moon. And yet, even here, life stirs. Shapes move. Shadows pass. Cameras catch flashes of motion that biology cannot name. These are the encounters, recorded, studied, but still unexplained. Every dive into the Mariana Trench is a negotiation with extremes. Temperatures hover just above freezing. Pressures exceed 1,000 times what we experience at sea level. Metal crushes. Light is absent. And yet, somehow life endures. More than that, it surprises. During a Japanese Shinkai 6500 mission, cameras captured footage of a translucent, disc-like creature drifting at over 6,500 meters. It pulsed rhythmically, not quite like a jellyfish, and had no tentacles or obvious method of propulsion. Instead, it seemed to hover with purpose, altering its shape to navigate currents. It shimmered with faint green light, an anomaly, since most deep-sea bioluminescence is blue. It has never been identified. Some researchers call it the ghost saucer. Further down, near 8,000 meters, autonomous landers recorded footage of a long, serpentine organism moving across the seafloor. Unlike eels or known ribbonfish, this creature lacked visible fins or segmentation. Its body flexed in wide, fluid arcs, as if it were one continuous muscle. Sonar confirmed its length at nearly 3 meters. It left no disturbance in the sediment and reacted to neither sound nor light. Analysis ruled out cables, detritus, or known fauna. It was listed as an anomalous elongate locomotion event. The name means nothing, but the footage is real. One of the most discussed and perplexing. Sightings occurred during the deep-sea Challenger dive led by James Cameron. While much of the journey was meticulously documented, there are moments in the footage where small, flickering lights appear in the periphery. They resemble fireflies. But in the Mariana Trench, there are no known species that behave this way. Later dives attempted to locate similar displays. In one case, a slow burst of dim pulses formed what looked like a spiraling column, rotating slowly, disappearing after 30 seconds. Scientists reviewing the footage remain divided. Some suggest a unique swarm behavior. Others suspect mechanical artifact. No one agrees. Biologists working with the Hadal Ecosystem Studies, Hades, program also documented strange movements near the Serena Deep, a lesser-known trench within the Mariana system. There, a camera recorded a group of benthic creatures resembling isopods, but each was translucent, with interior organs that shifted colors, from pale blue to milky white in rhythmic patterns. They were larger than surface isopods, up to 40 centimeters long. But their most mysterious feature was their stillness. For 22 minutes, they did not move, even as other life passed by. Then, all at once, they scattered in unison. The reason? Unknown. In another dive, a remotely deployed bait trap filmed a strange visitor, a creature with an ovoid body, long trailing filaments, and a large dark eye set near its base. It approached slowly, then circled the bait, never feeding. The filaments flexed and contracted, seemingly in response to submersible slights. This creature appears in only one frame, then vanishes. Some say it was a jellyfish. Others believe it to be a siphonophore colony. But its symmetry and movements don't match any known species. Sound recordings from the trench also suggest encounters with the unknown. Hydrophones deployed near the Challenger Deep captured an irregular series of low-frequency pulses, each about 7 seconds apart, descending in tone like a drawn-out sigh. This sound repeated every 45 minutes over a span of 4 days. No seismic activity occurred. No submarines were present. The pulses were not whale song or mechanical in origin. To this day, the Mariana Moan, as it's been unofficially dubbed, remains unclassified. Even within the realm of known life, the trench produces creatures so strange that their very biology resists taxonomy. The Hadal snailfish, discovered at depths over 8,000 meters, has bones that appear porous like foam, skin thinner than paper, and enzymes in its blood that counteract the crushing pressure. It seems fragile, but it is dominant in its own. Its success is unexplained. Why has evolution favored this body plan in a place so extreme? Then there are the visitors that leave no image, only traces. On several dives, sediment samples have returned with DNA from organisms never visually confirmed. These traces suggest vertebrates, but not matching any known fish or reptile. The sequences are incomplete. Some may be contamination. Others, especially those found in repeat samples, hint at species that live out of sight, avoiding light, bait, and noise. And finally, there are the unexplained shadows. Operators of the Chinese submersible Fendu's reported brief moments of sudden darkness during its record-setting dive to over 10,900 meters. Not equipment failure, not sediment plume. Something passed overhead, slowly, deliberately, blocking the sub's light sensors before vanishing upward. No video was captured, only sensor data. It may have been a large fish, or it may have been something else. The Mariana Trench is not empty. It is not silent. It is not still, but it is protective. It hides what it contains. For every known snailfish, there is a ghost saucer. For every map ridge, there is an unmapped echo. The trench gives us data, but never clarity. And perhaps that is its message. At Earth's deepest point, our tools falter. Our names fail. The creatures we find do not want to be found. They exist between frames and sensor glitches, in ambiguous shapes behind shimmering currents. They are not here to be understood. They are simply there. And in the deep quiet of the trench, the question lingers. Not what have we seen, but what have we missed? In research labs across the world, in basements of universities and behind quiet shells of marine institutes, there are shells of jars, rows upon rows of preserved life forms plucked from the deepest parts of the ocean. Some are gelatinous blobs, others rigid and alien, some strikingly beautiful in their symmetry, and others utterly formless. They rest in silence, suspended in alcohol or formalin, labeled not with names, but with numbers. Their tags read Unknown, Mariana 2014, or Specimen 8865. There are thousands of them, creatures without names. For every organism that earns a Latin binomial, a classification, a write-up in a marine biology journal, there are dozens, sometimes hundreds, that remain frozen in scientific limbo. Many have been physically collected. Some have only been seen in footage. But they all share one fate. No one has yet had the time, or perhaps the courage, to try and name them. Naming is not simple. It requires full anatomical analysis, dissection, genetic sequencing, comparison to all known species. A single formal description of a new species can take months, sometimes years, of patient, careful study. And the deeper we go, the more unfamiliar the life forms become. At the edges of what we understand, everything starts to blur. In deep-sea expeditions, especially those involving ROVs, researchers often bring back hundreds of new organisms from a single dive. These might be tiny worms living on the back of a larger host. They might be translucent jelly-like animals that melt quickly outside their pressure zone. Or they might be complex and hardy, surviving even in collection tanks. But the sheer volume of discovery has overwhelmed classification. In one vault at the Smithsonian National Museum of Natural History, over 10,000 marine specimens remain undescribed. Some have been sitting in storage since the 1970s. Many were collected during Cold War-era deep-sea missions, when exploration was more frequent than documentation. These creatures were captured, preserved, and left in line, waiting for a biologist to choose them. Some will never be studied. Digital footage faces the same dilemma. ROV dives capture countless hours of video, often showing creatures that flit into view for only seconds. These glimpses are logged with timestamps and descriptions, unidentified siphonophore-like structure or possible new polychaete behavior. But there simply aren't enough specialists to review it all. Ocean Networks Canada, Jamstack, NOAA, and others host archives with terabytes of data. In these tapes are organisms no one has seen before. They flicker past the camera and vanish. There's a term for these, orphans of taxonomy. They exist. We know they exist. But they have not been adopted by science. Without a name, they have no story. They cannot be protected. They cannot be fully studied. They float in a scientific purgatory. Part of the problem is structural. Deep-sea biology is chronically underfunded. Specialists in obscure taxonomic fields are rare. A biologist who understands one family of jellyfish may have no training in another. There is no universal manual for deep-sea life. Each discovery may require new methods, new categories, entirely new language. Some creatures resist classification entirely. A transparent organism caught near a hydrothermal vent might defy all known phyla. It may have features of multiple groups, tentacles like a cnidarian, segmentation like an annelid, but DNA unlike either. Scientists hesitate to name what they don't understand. Better to wait, to collect more samples. But samples are hard to get, so the creature waits unclassified. There's a jelly-like organism seen in the footage from an abyssal dive near Tonga. It pulses but doesn't swim. It anchors to a rock but detaches when disturbed. It has no visible mouth, but absorbs surrounding particles. Its body is structured into 5 lobes, which no known jellyfish possesses. It appeared once, in 2018. It was recorded, archived, and never seen again. Its video is labeled unidentified, possibly gelatinous colony. There's also the problem of partial specimens. A deep-sea trawl might bring up a piece of a creature, a single fin, an arm, a slice of tissue. Without the full body, naming becomes guesswork. Is this a new species? A larval form? A malformed individual? Many of these pieces are stored, frozen or fixed, waiting for something to match them. Some remain unmatched for decades. Every few years, someone reopens a jar, a graduate student working through a thesis, a curator dusting old shelves. Occasionally, something is re-examined and published. A 1982 specimen reclassified, a forgotten creature finally named. But for most, the wait continues. This backlog is not just a logistical issue. It is a philosophical one. In our rush to explore, to film, to collect, we have flooded ourselves with more life than we know how to honor. And naming is, in many ways, a form of honor. To give a creature a name is to acknowledge its place in the world. Without one, it drifts, known but unclaimed. And yet, even unnamed, these creatures teach. Their forms inspire questions. Their structures hint at functions unknown. They remind us that the ocean is not ours. It is not fully mapped, not fully known. It resists cataloging. Some researchers now use AI to assist in sorting footage and identifying recurring shapes. Programs trained on known species can flag the unusual. This helps, but it doesn't solve the problem. Machines can't name. They can only point. And so the ocean's forgotten remain. In cool storage rooms, in digital files, in frames of video watched once and logged. Their mystery intact. To walk through one of these vaults is to see time paused. Jars line the walls. Tags yellow with age. Bodies curve in unnatural ways, preserved in mid-motion. Some look like seaweed. Others like crystals. A few appear to be staring back. Each one holds a story we haven't written. A thread of evolution untraced. A piece of the puzzle we didn't know was missing. Perhaps that's the quiet truth of the deep sea, not that it is unknowable, but that it is overflowing. It gives more than we can handle. More forms, more beauty, more complexity. We are not short on data. We are short on time. So they wait, the creatures without names. In liquid, in silence, in memory. Not forgotten. Not yet. Just waiting to be seen again and finally understood. Long before sonar, before submarines, before the ocean's floor had even been imagined, there were stories. Sailors told of enormous shadows beneath the waves. Ancient texts describe creatures with eyes like lanterns and limbs like ropes. In every maritime culture, from the Norse to the Polynesian, from coastal Japan to Mediterranean harbors, the sea was not just vast, it was inhabited, populated by beings strange, terrifying, and sometimes eerily familiar. These were the legends from below. Some tales were born from fear. The ocean was an unknowable thing. It swallowed ships, changed moods without warning, and made no distinction between king or commoner. In that terror grew stories of tentacle horrors, scaled giants, and seductive beings that lured sailors to their deaths. But as deep-sea exploration has advanced, a strange realization has emerged. Many of these myths may not be inventions. They may be interpretations, early, emotional responses to encounters with real, though unclassifiable, life. Take the Kraken, one of the most iconic sea monsters in Scandinavian legend. Described as a creature so vast it could be mistaken for an island, the Kraken would rise from the depths, create whirlpools, and drag entire ships to the bottom. For centuries, it was considered fantasy, until sightings of giant squid began to surface. These elusive creatures, once considered mythical, are now confirmed. With eyes the size of dinner plates and tentacles lined with hooks, they match many elements of the Kraken legend. Their movements are rarely seen, but when they breach, they do so suddenly with force. For a sailor in the 13th century, such a glimpse might indeed look like a beast the size of a small landmass. Or consider the sea serpents recorded in 19th century ship logs. The HMS Daedalus famously reported an enormous snake-like creature in 1848, seen by multiple officers. At the time, scientists were skeptical, but now we know of ribbon-like creatures like the oarfish, capable of reaching lengths over 10 meters, with shimmering silver bodies and crest-like dorsal fins. The oarfish lives in deep water and rarely surfaces, but when it does, it swims close to the surface, undulating vertically, a motion unlike any known fish. Could this be the serpent? In Japanese folklore, there is a yumabozu, a shadowy, humanoid figure said to rise from calm seas and capsized ships. It was considered a spirit or a punishment, but deep-sea ROV footage has shown translucent, gelatinous organisms rising vertically with no visible arms or legs, their forms distorted by currents and light. These illusions, combined with fear and isolation, may have given rise to the idea of something sentient and watching. Indigenous Hawaiian stories speak of the MOO, giant water lizards that lived in ponds, rivers, and the sea. Described as intelligent and territorial, they were said to guard sacred places. While no such reptile has been found in Hawaiian waters, recent discoveries of large predatory eels and deep-sea cephalopods near hydrothermal vents suggest that ancient observers may have seen something unusual, something that inspired stories of guardianship and boundary. Even mermaids, often dismissed as pure myth, may have roots in misidentified marine mammals. Sailors exhausted from long voyages reported seeing women with long hair and fishtails basking on rocks. Some of these sightings occurred in regions home to dugongs or manatees. In poor visibility and through the lens of longing and fatigue, a half-seen creature might become something else entirely. But in the deep sea, there are also beings with vaguely humanoid symmetry, siphonophore colonies that form shapes reminiscent of torsos and arms, or translucent jellies with eye-like photophores and trailing appendages. Their forms mimic suggestion. Our minds fill in the rest. One of the oldest myths comes from Greek antiquity. The story of Scylla, a monster with 12 feet and 6 heads, who lived in a narrow strait and snatched sailors from their ships. This might have been a way to explain dangerous currents, but it also aligns strangely with descriptions of siphonophores or comb jellies that form multi-lobed, coordinated shapes. Some even pulse with multiple heads, each part a colony in itself. And from the West African coast comes tales of Mami Wata, a sea spirit said to be beautiful, unpredictable, and capable of both healing and destruction. She is often portrayed as half fish, half human, like mermaids, but with a more fluid and shifting form. While culturally rich and symbolic, the image may also reflect encounters with bioluminescent creatures that glittered and moved in unpredictable ways, sea beings that appear to transform under changing light. The legends are not limited to the distant past. In the 20th century, stories from deep-sea fishermen in the North Atlantic spoke of whistling fish, organisms that made high-pitched sounds before storms. For decades, this was assumed to be fiction. But in recent years, hydrophones have captured rhythmic chirping and high-frequency pulses from unidentified organisms, particularly during changing barometric conditions. The idea that animals might sense and signal weather is no longer entirely dismissed. Then there are the lights. Mariners from multiple cultures have told of glowing orbs beneath the surface, will-o'-the-wisps of the sea. Some believe they were spirits. Others thought them omens. Today, we know of bioluminescent creatures like the firefly squid, the flashlight fish, and entire schools of glowing copepods that can make the water appear lit from within. In large numbers, these creatures create drifting constellations, a sea full of stars. For ancient sailors without scientific language, spirit may have been the closest word. What these stories show is not just the imagination of humanity, but its deep sensitivity to the unknown. Before taxonomy, before biology, people still observed. They named what they saw. They shared what they feared. And in many cases, they may have glimpsed things we are only now beginning to understand. Modern science often separates itself from myth, but in the deep ocean, that line grows thin. With every new ROV dive, we encounter creatures that match the tone, if not the detail, of stories told in candlelight centuries ago. The fear, the awe, the reverence remain. So when we hear tales of sea monsters or strange beings from below, perhaps we should not ask whether they are real or not. Perhaps the better question is, what did those stories remember? What did they preserve? Because in the deepest part of the ocean, where cameras flicker and light bend strangely, where shadows stretch and disappear, it is not hard to believe that some legends were not born from fiction, but from truth glimpsed once, long ago, and carried forward in story. For centuries, the deep sea was thought to be lifeless, a dark, cold, high-pressure wasteland where nothing moved and nothing could survive. It was assumed that beyond a certain depth, past the light, past the warmth, past the reach of ordinary observation, the ocean gave way to emptiness, a void of water and silence. But the truth, revealed in fragments through decades of exploration, is far more astonishing. The deep sea is not empty. It is vibrant. It is densely populated. It pulses with life we've only begun to see. From the outer edge of the continental shelf to the Hadal Trenches, each zone teems with organisms adapted to survive in precise, complex, often counterintuitive ways. Some are microscopic, drifting through the water in filaments and clouds, barely distinguishable from detritus. Others are enormous, slow-moving, ghost-like in their appearance, but perfectly at home in their world of pressure and dark. Beneath 200 meters, light begins to fade. Below 1,000 meters, it disappears altogether. And yet, many of the densest layers of life reside within this mid-water twilight. In the mesopelagic zone, the so-called deep scattering layer is a living cloud, composed of millions of tiny organisms, lanternfish, shrimp, squid, jellyfish. It moves rhythmically, rising toward the surface each night in the largest migration on Earth, then sinking back by day. This vertical commute, invisible from above, regulates planetary carbon, feeds surface predators, and drives the base of deep ocean food webs. Go deeper, and the abundance continues. On the abyssal plains, those flat, silted stretches once believed lifeless, ROVs now reveal bustling communities. Sea cucumbers, brittle stars, glass sponges, deep-sea octopuses, and countless worms populate the sediment like stars across a dark sky. At any given time, multiple creatures pass through a single camera frame. They may not dart or flicker, but they move, they feed, they respond. Even more concentrated are the ecosystems around hydrothermal vents. These deep, volcanic chimneys spew mineral-rich fluids into surrounding water, fluids that would be toxic to most known life. And yet, around them cluster thriving biological communities, giant tube worms, clams with symbiotic bacteria, eyeless shrimp, and strange crabs with furred claws. These animals don't rely on sunlight. Instead, they depend on chemosynthesis, a process in which microbes convert chemical energy from a vent fluid into usable food. This is life without the sun, life in complete darkness. And there are more vents, more seeps, more underwater mountains than we can possibly survey. Every new dive reveals something strange, something unclassified, something alive. The seamounts that rise from the abyss support coral forests, anemone gardens, and schools of fish adapted to cold and depth on vertical cliffs. Even in currents that never stop, cling organisms that have learned to harness movement and stillness alike. Everywhere we look, we find life in forms that challenge our imagination. A jellyfish with arms longer than a bus, able to curl and uncurl like ghostly fabric. A worm that builds its own glass shell. A fish that produces its own antifreeze proteins. These are not isolated miracles. They are part of a rich and ancient network. The perception of deep-sea barrenness has lingered largely because of how difficult it is to study. Sampling is limited. Visibility is poor. Conditions are harsh. In early exploration, when nets were lowered and retrieved, only a few damaged specimens came back. This scarcity fed the myth of emptiness. But now, with high-definition cameras and general robotic arms, we see what was always there. Even in the hadal zones, the trenches and cracks deeper than Mount Everest is tall. Life is present. Amphipods swim freely. Snailfish float just above the bottom, translucent and resilient. Bacteria line the walls. Entire ecosystems cluster around the remains of fallen whales or sunken wood, creating temporary oases in an otherwise silent landscape. Life in the deep is not evenly distributed. It is clumped, organized, deliberate. Where there is a rock, there is often a coral. Where there is coral, there are shrimp. Where there is shrimp, there are predators. It is a quiet web, but a strong one. And above all, it is diverse. Biologists estimate that as much as 2/3 of marine species may still remain undescribed, and many of those are likely deep-sea dwellers. Each expedition turns up organisms that resist classification. Jelly-like creatures with no known relatives, worms that photosynthesize without sunlight, animals that defy phylum altogether. The tree of life does not taper into the deep. It expands there. More than that, the deep sea is active. It is not a stagnant world. It breathes with currents. It resonates with sound. Its creatures migrate, reproduce, interact. Deep-sea sharks traverse thousands of miles. Sperm whales dive for squid in coordinated hunting. Even the bacteria collaborate in vast colonies that cycle nutrients and generate energy. The stillness of the deep is deceptive. Like the surface of a forest at dusk, it seems calm until you listen closely. Then, every inch reveals motion, gentle, purposeful, alive. And what we see is only a fraction. The lights of an ROV reach only a short distance. Cameras record what is directly in front. Much is still hidden just outside the beam, just beyond the frame. In those shadows are whole ecosystems, entire narratives of feeding, drifting, birthing, and death. The deep sea is not barren. It is simply subtle. In some ways, the illusion of emptiness is comforting. It suggests a boundary, a place where the world stops. But the reality is more profound. There is no edge. The deep continues, filled with life and forms we are still learning how to see. And in this lies the quiet majesty of the ocean's depths, not just in the monsters or mysteries, but in the ordinary miracles that happen in darkness every day. To call the deep sea empty is not just inaccurate. It is a refusal to look long enough. Because when we do, when we peer through the dark and the pressure and the stillness, we find a world that was never lifeless, only overlooked. At the bottom of the ocean, where sunlight cannot reach, where the water is cold and the pressure would crush most known life, there are creatures that breathe something else entirely. Not air, not light, but chemicals. Gases that, on the surface, are known for their toxicity. Methane, hydrogen sulfide, ammonia. Down here, these are not poisons. They are nourishment. They are the fire in the deep. This is life not fueled by the sun, but by the earth itself. These strange ecosystems cluster around hydrothermal vents and cold seeps, cracks in the ocean floor where heat, minerals, and chemicals flow from the planet's interior. From a distance, the vents appear like underwater chimneys, expelling shimmering plumes of superheated water. The seeps are quieter, often hidden, releasing methane and other gases slowly into surrounding sediment. In both cases, what should be barren wasteland instead becomes a living oasis. The most iconic inhabitants of these places are the giant tube worms, Riftia pachyptila. They rise in clusters like underwater reeds, white and red, anchored in rocky outcrops near vents. Each worm can grow more than 2 meters long. They have no mouth, no stomach, no digestive tract. Instead, inside their bodies is an organ called a trophosome, home to billions of chemosynthetic bacteria. These bacteria take in hydrogen sulfide from the vent water, an otherwise deadly gas, and convert it into organic compounds. The worm, in turn, lives off this chemical nourishment. It breathes not oxygen, but sulfur. It digests nothing, and yet it thrives. Nearby are vent crabs and blind shrimp, their exoskeletons often covered with mats of bacteria. Some species cluster directly on the vent openings, where temperatures can rise above 300 degrees Celsius. Their secret is positioning, just far enough from the vent to avoid the boiling water, close enough to absorb the chemicals. The shrimp, in particular, host special bacteria on their shells that process hydrogen sulfide or methane. These bacteria form a kind of living layer, a symbiotic coat that not only feeds the shrimp, but may offer protection from heat and toxins. The cold seeps, though less dramatic, are equally mysterious. Here, in dark plains far from volcanic activity, gases like methane rise up through the sediment, and around them gather unique ecosystems. Clams, mussels, tube worms, and bacterial mats. These organisms, too, rely on symbiosis. Their bodies are often embedded with bacteria that can metabolize methane, a gas that burns on the surface, but down here fuels life. Some species of mussels that methane seeps have been found with entire bacterial communities inside their gill tissue. The bacteria convert methane into sugars, which the mussels absorb. These mussels have little need to filter plankton or organic matter. Instead, they farm energy from gas. It is as if the laws of biology have been rewritten at these depths. The usual rules, eat, hunt, graze, are replaced with partnerships, with quiet exchanges between animal and microbe, between body and chemistry. The vent worm does not seek food. It is food growing from within. The shrimp does not scavenge, it cultivates. And these organisms are not rare. Hydrothermal vents and methane seeps are scattered throughout the world's oceans, from the East Pacific Rise to the Mid-Atlantic Ridge, from the Arctic to the Gulf of Mexico. At every location, we find variations on this theme. Creatures built to live not in light, but in chemistry. Some live only a few meters from vents. Others settle miles away, drawing on the trace particles that drift from these unseen furnaces. Perhaps most astonishing is how quickly life colonizes these places. When a new vent opens, a fissure from volcanic activity, organisms arrive within weeks. Larvae from worms and shrimp drift through the currents, somehow sensing the chemical signals. They land, settle, and begin to grow. The bacteria arrive too, or are carried within them. In this way, life spreads not from sunlight, but from fire and gas. This is not fringe biology. This is a parallel system of life, one that may resemble how life first began. Before plants, before animals, before photosynthesis, there may have been chemosynthesis. In Earth's earliest days, when the atmosphere was young and the sun's energy was filtered through thick clouds, it is possible that the first cells drew power from sulfur and methane, not light. The creatures at these vents may be their descendants, not survivors of a past extinction, but continuations of a deeper, older lineage, a memory of a time when breathing fire was the only way to live. And as we look outward, toward other oceans, other planets, these creatures offer a model. On Europa, the icy moon of Jupiter, or Enceladus, the moon of Saturn, there may be subsurface oceans. Scientists believe these oceans could contain hydrothermal activity. If so, the potential for life does not depend on sun or sky, but on chemistry. The same partnerships we see in riftia worms or seep clams might be mirrored in some alien sea. Back on Earth, the more we study these creatures, the more we realize how much we've missed. There are species we filmed but never named. Chemical processes we don't fully understand. Organisms that survive in temperatures and acidities we thought impossible. What unites them all is a kind of quiet resilience. They do not hunt. They do not flee. They do not move quickly, but they endure. They thrive. They turn gas into life, fire into form. In the dark, at the edge of tectonic plates, life writes its own rules. It breathes fire, and it lives not in defiance of an environment, but because of it. There is a boundary we speak of often in oceanography, the Hadal Zone, named after Hades, the ancient Greek underworld. It begins at 6,000 meters and descends into the planet's deepest trenches. These are the darkest, most pressurized, and least explored places on Earth. But even here we do not reach the end. For beyond the trenches, beyond what our submersibles and sensors can currently reach, lies something more. A realm unnamed, a space unmeasured. The ocean, as it turns out, doesn't end. We've mapped the trenches only in broad strokes. The Mariana Trench, the Chromatic, the Philippine Trench. These cracks in the seafloor drop far beyond the reach of light, heat, and most of our technology. Only a handful of dives have reached the Challenger Deep, the trench's lowest point, at nearly 11,000 meters. Those that did, like the Trias in 1960 or James Cameron's solo descent in 2012, stayed only for minutes, saw only what a small spotlight could reveal. And yet even these record-setting dives touch just a narrow point. The full terrain remains unseen. But there are hints that below these known zones, stranger depths continue. Some researchers speculate that ultra-deep rifts, narrow, twisting channels within trenches, may descend hundreds of meters farther. These may be impossible to detect from satellites or sonar alone, especially if they are small, steep-sided, or folded within unstable terrain. Seismic readings sometimes suggest sudden drops in the seafloor, moments where waves bounce from depths lower than recorded trench bottoms. Some of these signals are dismissed as anomalies. Others are left unverified, but they whisper of something deeper than what we've charted. In subduction zones, where tectonic plates grind together and one slides beneath the other, material is pushed downward into the mantle. In theory, water may be dragged with it. Some geophysicists believe that pockets of ocean water, trapped and pressurized over millions of years, may exist miles below the seafloor. If life can exist at hydrothermal vents, fed by chemical reactions rather than light, might it also persist in these hidden aquatic pockets? Could entire ecosystems exist, undisturbed and unknown, under the trenches themselves? What would such organisms look like? Surviving in complete isolation, fed only by minerals, heat, and pressure? Would they resemble the extremophiles we already know, or follow entirely different evolutionary paths? Would they have form at all, or be single-celled, diffuse, microbial clouds drifting in hidden reservoirs? Our deepest ROVs and landers face limits. The crushing weight of water at 11,000 meters is nearly 1,100 times atmospheric pressure. Most materials fail at those levels. Electronics short, housings collapse, even titanium bends. To go deeper into the speculative ultra-hadal zone would require technology we haven't yet invented, which means our curiosity extends beyond our reach. There are sounds, too, recorded by deep-sea hydrophones, whose sources remain unclear. Deep thuds, rhythmic pulses, low, haunting tones that stretch across ocean basins. Some of these may come from geological movement, others from whale calls, distant and distorted, but a few seem to originate from depths greater than where known animals dwell. Without eyes there, without instruments that survive long enough, we cannot be certain. We can only listen and wonder. Some researchers have suggested that the hadal trenches may act as species vaults, preserving ancient lineages that disappeared elsewhere. If so, what might lie in deeper rifts? Not new species, perhaps, but very old ones. Creatures from before the continents drifted apart. Beings unchanged not just for millions, but for hundreds of millions of years. In this way, the ocean becomes not just a physical space, but a geological memory, a vault of life's oldest shapes. And the lower we go, the further back we travel, not just in depth but in time. There's also a philosophical dimension to this. The idea that something could exist beyond our current comprehension is both humbling and exhilarating. It recalls an older way of thinking, when maps marked uncharted territories with dragons or whispered of lands that fell off the edge. We no longer fear sea monsters, but we still fear the unknown. And the ocean at its deepest offers a pure unknown. In 2019, a Chinese crewed submersible reached 10,909 meters in the Mariana Trench. It was the deepest manned dive to date. Cameras showed amphipods, sediment, and strange, thin-bodied creatures undulating just above the bottom. But even there, the vehicle could only hover. It could not descend further. Sensors indicated possible movement below, a softness to the sediment, a hint of flow. But without better tools, we were left with questions. The ocean is vast not only in width, but in vertical complexity. It folds in layers. It hides within itself. Just as mountain ranges have foothills and peaks unseen behind the first line of ridges, so too may trenches hide lower trenches. We map with sonar, but sonar blurs. It shows outlines, not details. And the deeper we go, the blurrier it gets. What In the fold of these trenches, there are corridors of pressure and heat that descend even farther. What if life there exists not in silence, but in communication, using chemical signals or vibration or slow exchanges of heat? What if it is not rare but dense? What if we've mistaken difficulty of access for emptiness? For now, these questions remain unanswered, but they invite a kind of scientific reverence. The ocean does not end. Our knowledge does. And in that space, in that gap between what we can see and what we can imagine, lives the future of deep-sea exploration, not in the belief that we've reached the bottom, but in the quiet certainty that we haven't. In the quiet blackness beneath 6, 7, 10,000 meters of ocean, science does not move quickly. It slows. It pauses. Down there, where the rules bend and known forms dissolve into strangeness, even the most advanced methods falter. Pressure crushes. Cold preserves. Light vanishes. And the life that thrives under these impossible conditions refuses to be easily named. It is here, in these depths, that science, so confident on land, becomes humble. Because in the deep sea, classification does not lead. It lags behind the mystery. We think of science as forward-moving, discovering, identifying, cataloging. But in the abyss, these steps become complex. The basic act of observing is hard enough. Cameras work only within narrow cones of light. Samples brought to the surface rarely survive intact. Organs collapse. Cells rupture. Gels solidify. Even if we catch a creature, it changes on the way up. What we retrieve is often not what lived below, but a distorted version, a suggestion of something whole. Consider pressure. At 10,000 meters, every square inch of a creature's body endures over a ton of force. Life there is adapted not by strengthening, but by yielding, becoming soft, gelatinous, almost liquid in texture. These bodies are not meant for the surface. Bring them up, and they fall apart. We can't dissect them with the same tools used on surface fish. We can't freeze them. We can't always preserve them. They vanish between states, between forms. Temperature, too, is a gatekeeper. The deep sea is near freezing. Enzymes function differently at 2 degrees Celsius. Cell membranes become more flexible or rigid depending on depth and species. Some life depends on cold. Remove it, and metabolism stops. Others, especially those near hydrothermal vents, rely on heat gradients that cannot be replicated on land. In labs, under controlled temperatures and atmospheric pressure, their behavior, if any, is altered beyond recognition. Then there is isolation. Many deep-sea organisms are not single species, but symbiotic systems. Tube worms are house bacteria, clams with internal chemical processors. Jellies form from colonies rather than individuals. To observe them properly requires not just one sample, but the environment they grew in. Without the surrounding chemistry, without the slow current in the quiet dark, something essential is lost. A coral plucked from 7,000 meters may survive for a moment in a tank, but is alone, stripped of its living web. So classification becomes delayed. We take video. We log observations. We describe creatures in field notes with phrases like gelatinous ribbon-like organism, 3m long, undulating wave motion, no visible segmentation. We give them placeholder names, orb jellies, string ghosts, whale fall eel forms. But without repeated sightings, without physical specimens that remain stable, we cannot define species. And without species, we cannot place them into families, orders, classes. Some creatures have been caught on film only once, hovering behind an ROV, blinking lights across translucent flesh, then vanishing. Some are recorded only as fragments, tentacle tips, filaments, unidentified tissue floating past a lens. Others are detected only by sound or shadow, inferred from what moves the water, but never clearly seen. And even when samples do make it to the surface, their DNA is often difficult to extract. Some contain unfamiliar genetic codes or high levels of non-standard proteins. Others host multiple species in a single body, bacteria within worms, viruses within bacteria, symbionts that do not live anywhere else. This tangle makes sequencing complex. Results can take years. And in many cases, the outcome is uncertainty, unknown lineage, possibly novel phylum, insufficient data for classification. Taxonomy, the practice of naming and sorting life, relies on comparison. But in the deep sea, comparison often fails. What does siphonophore relate to? Is a glowing orb with 6 mouths an animal or a colony? Does a translucent predator that expands and contracts qualify as a jellyfish if it lacks the expected nerve ring or tentacle structure? And even when a new species is confirmed, publication can take years. Formal description requires multiple samples, detailed imaging, preserved tissues, DNA confirmation, and sometimes even reproduction or life cycle data. But most deep-sea creatures have never been seen more than once. They appear, then vanish. The deep does not offer repetition. It offers glimpses. So the backlog grows. In research labs and institutions across the world, specimen jars sit labeled with codes, not names. Footage files are tagged unknown gelatinous predator or possible siphonophore variant. Some have been waiting decades for re-examination. Many never will be. This is not failure. It is a natural pace of discovery in the most inaccessible habitat on the planet. It reminds us that not all science is rapid. Some knowledge takes time, years, lifetimes, generations. And there is beauty in this delay, in knowing that the ocean still resists our categories, that there are beings out there, floating, feeding, reproducing, that exist outside our books. They are not nameless to themselves, only to us. When we imagine the deep sea, we often picture monsters or silence. But more often, it is soft, unfamiliar life moving slowly, forming its own systems, thriving under rules we barely understand. Science pauses at pressure, because pressure is where the old models break down. In a way, the abyss is not a frontier. It is a mirror, reflecting how small our knowledge still is. Not empty, but rich with things we do not yet have language for. And maybe that is where wonder begins, not in classification, but in the space before it, where science watches, waits, and listens. Because in the deep, nothing rushes, and everything lasts. In the deepest fold of the ocean, there are creatures whose ancestors never once saw sunlight. Not a glimmer, not a filtered beam, not even a hint of glow through water. These are animals born into darkness, descended from darkness, adapted to darkness, so complete that light is no longer part of their reality. Here, in this absolute black, life has taken strange paths, unfolding in quiet, cryptic directions that break for what we know about biology shaped by the sun. Above the ocean, every living thing is tied in some way to light. Plants photosynthesize. Animals eat plants. Eyes evolve to seek brightness. Even sleep cycles are governed by day and night. But in the abyss, there is no day, no clock, no shadow, because there is nothing to block. And in this absence, evolution has moved in other directions, not forward or backward, but sideways, into strange and specialized shapes. Many deep-sea animals have no eyes at all, not reduced eyes, not poor vision, nothing. Some fish have evolved skin where eyes would be flat and smooth. Others carry only a cluster of light-sensitive cells buried deep in their heads, enough to detect faint bioluminescence, but not to form images. For these animals, vision is not a sense, it is a memory. But not all creatures in the dark give up on sight. Some, instead, evolve bizarre enhancements. Certain shrimp and squid have upward-facing eyes capable of detecting the faintest ambient light, perhaps the last traces of starlight or moonlight scattered from above. Others develop mirror eyes, which reflect and amplify dim flashes, like living telescopes. The barrel-eye fish, for instance, has tubular eyes encased in a transparent dome. Its retinas angled upward to catch silhouettes of glowing prey. These adaptations are not uniform. In some species, individuals from different depths evolve different traits, some blind, some semi-visual, even within the same genetic lineage. This hints at rapid and flexible adaptation, guided by subtle cues. Pressure, diet, faint chemical trails, and water. Without sunlight, other senses take priority. Many deep-sea animals have expanded lateral lines or electroreception, systems that detect vibrations, currents, or the weak electrical fields emitted by living tissue. Some sense temperature shifts. Others navigate by the chemical signatures of vent plumes or decaying matter. They do not see the world. They feel it. In the dark, color also fades. Pigmentation becomes irrelevant. Many animals are translucent white or a soft violet. Some have soft exteriors with no hard shell or bones. Instead of building armor against predators, they become ghost-like, hard to grasp, easy to hide. And yet, some species do carry pigment, vivid reds, deep blacks, even ultraviolet absorbing layers. Why? Because red light doesn't travel far in water. A red animal becomes invisible in the deep. And black, true black, absorbs even bioluminescent flashes, making an animal vanish into the void. These choices are not aesthetic. They are survival, an evolved absence, a strategic invisibility. The genetics behind this are equally fascinating. Many deep-sea organisms possess unusual mitochondrial adaptations, ways to process energy under low oxygen, high-pressure conditions. Some produce proteins not found in any shallow water species. Others replicate DNA at slower rates, possibly as a defense against the mutating effect of pressure and cold. Their genomes are full of unknown genes, sequences with no known function, no match in other animals. These orphan genes suggest independent evolutionary experiments, new solutions to ancient problems crafted in the dark. There are also strange choices around reproduction. Some species are hermaphroditic, capable of switching sex depending on environmental cues. Others reproduce asexually or release vast clouds of larvae into currents, trusting the abyss to carry them somewhere survivable. A few species seem to sync their reproduction with phases of the moon, even though they have no eyes and have never seen the moon. The mechanism is unknown. It may be chemical, or magnetic, or something we've not yet named. And while evolution often pushes toward complexity, in the deep sea, simplification can be an advantage. Eyes vanish, bones soften, immune systems are streamlined, energy use is minimized. In this way, some deep-sea organisms may resemble ancestral life, primal, efficient, unburdened by unnecessary traits. But it would be wrong to call this regression. Simplicity in the deep is not a lack. It is a form of mastery. These creatures are not remnants. They are experts, refined over millions of years to thrive in a place most organisms cannot reach. There is also the matter of time. Life in the deep evolves slowly, with stable temperatures and fewer predators. Changes happen across vast spans. Some creatures may have remained unchanged for tens of millions of years. Others may mutate rapidly in response to the subtle shifts of deep ocean currents or seismic activity. Evolution, here, is patient but sharp. And while we search for patterns, some organisms seem to defy classification entirely. Species found near vents, for example, may combine traits from multiple phyla. Some jellies don't resemble any known lineage. A few samples contain genes thought unique to bacteria, hinting at past symbioses or horizontal gene transfers no longer seen in the shallows. All of this challenges the way we understand life. On land, evolution is shaped by light. In the deep, it is shaped by absence. Not a void, but fertile waiting dark. A space where adaptation follows other rules, other rhythms. And so, when we look into the abyss, we do not find emptiness. We find life that has never needed light. Life that does not know we exist. Life that is not shaped by being seen, but by enduring quietly without witness. It is a reminder that evolution is not linear, not upward, not always toward brightness. Sometimes it moves inward, into silence, into simplicity, into otherness. And in doing so, it makes something entirely new. There are places on Earth we will likely never touch, not because they are far or forbidden or dangerous, but because they are quiet, because they do not rise, because they do not wait to be found. The deep sea, with all its strange breath and stillness, may remain the greatest mystery we have. And though our lights have dipped into it, though our machines have hovered and blinked and recorded, there is so much we might never know. A single camera passing to the black might catch a creature we'll never see again. A slow-moving orb, a transparent tendril, a jelly with ribs of flickering red light. It drifts in the water, unbothered by the presence of the machine. Perhaps it has never seen another object before. Perhaps it has. The camera continues on. The creature remains behind, vanishing into the darkness. We save the footage. We give it a name we made up. But it does not need a name. It is what it is. And we may never see it again. Even now, in labs and archives around the world, are images and samples that remain unexplained. Footage of animals with no known relatives. Tissues collected from depths with DNA that resists classification. Fragments of life caught in the edge of a frame. They sit quietly, awaiting someone who might take interest, who might find the time to look again. But even if they do, the creature that left them behind might have vanished, receded into its lair, returned to whatever silent web it lives within. The ocean is not still. It moves. Currents carry things thousands of miles. Deep layers shift, rise, fall. What is visible in one moment may be unreachable in the next. A trench may collapse. A vent may cool. A population may disappear. In the span of a few years, an entire ecosystem can emerge and vanish, seen once, never again. And yet, the more we search, the more we realize the deep sea isn't empty. It's overflowing with life, with silence, with questions that fold into more questions. Why do some creatures glow red in a world where no eyes can see red? Why do others grow to monstrous size in the deepest cold? What do they eat? How do they find each other? Do they know they are alone? Some questions may be answered with time and technology. Others may never be. And perhaps they don't need to be. There is comfort in knowing that mystery still exists, that there are places untouched by headlines or speed or light, that the world, even in an age of satellites and sensors, still keeps a part of itself hidden, not maliciously, not teasingly, just quietly. The ocean doesn't demand to be known. It allows glimpses. It lets us wonder. And maybe wonder is enough. There's a kind of peace in letting go of the need to define everything. A kind of humility in knowing that life goes on without us, in patterns we don't understand, in rhythms we can't hear. We are not the center. We are not the authors of everything that moves. We are simply visitors, brief observers, lights that flicker once and fade. The deep sea will continue long after we stop watching. Creatures will pulse and drift, feed and birth and dissolve in the black. The vents will open and close. The trenches will deepen. The ocean will remember things we've never seen. And if we're quiet enough, if we stop trying to claim it, or explain it, or conquer it, we might hear something back. Not a voice, not an answer, but a kind of presence. A reminder that mystery isn't something to be solved. It's something to be shared. What we might never know is vast. But so is what we have seen. A jelly that moves like breath. A squid with arms that fold like petals. A worm that glows from within. A fish that floats like a shadow, watching something we cannot. These are not failures of science. They are gifts, glimpses, and they are enough. The ocean, now still, seems to breathe in long, deep intervals. Down where no sunlight has ever reached, where pressure presses like a slow and endless weight. The creatures of the deep continue their ancient drift. They do not sleep as we do. They move gently, deliberately, not in haste but in harmony, with currents, with darkness, with time itself. It is here, in this hushed and weightless world, that we leave our journey. Somewhere, a jellyfish pulses softly, its tendrils drawing subtle shapes in the water, glowing faint blue in the black around it. It is not moving toward anything. It is not running from anything. It simply exists, glowing, turning, quiet. Far below it, a glass sponge filters invisible particles, unmoving yet alive, its lattice shell older than many cities on land. Nearby, a blind shrimp senses warmth from a vent, its tiny hairs twitching in response. Nothing here is in a rush. Everything has time. The deep sea is not a place of emptiness. It is full of presence, of pressure, of long memory. We call it alien, but it is part of our own world, just hidden from us, a secret that has never needed to be told. And tonight, we wander through its layers, through shadow and silence, through the strange language of bioluminescence, through forms that seem impossible and yet endure. There is comfort here, not in knowing, but in accepting, in letting mystery lie where it belongs, in knowing that while we sleep, The ocean continues, just as it has for millions of years. Its creatures glow and fade, drift and return, in rhythms older than language. So let the light fade now. Let the last images drift in your thoughts. The slow undulation of a giant jelly. The coiling arms of squid disappearing into shadow. The soft flash of an unseen eye blinking once, then closing forever. The surface may be bright with waves and wind, but here in the depths, all is calm. The kind of calm that is not empty, but full. The kind of quiet that holds stories. The kind of dark that nurtures life. Sleep now with the ocean beneath you. Let its weight cradle you. Let its silence carry you. Good night from the deep.